Hello everyone, a very good morning to all of you. First and foremost, if the audio and video are working fine, please let me know. Great. So let's begin with our session. So today we are here with the last session on science and technology. So there are two things that we're going to discuss. First, the continuation of the chapter that we started last time, that is IT and communication. And first we'll complete the chapter of IT and communication. And after that, we'll begin with our last chapter, that is intellectual property rights. So these are the two things that we are going to do in today's class. Also to mention that in tomorrow's class, we are also going to have a doubt session where every doubt that you have with regards to whatever we have discussed over the last couple of weeks, you can ask whatever you want. We shall also discuss some of the questions from 2023 paper in tomorrow's session. So these are the things that we'll discuss. I'll basically discuss the prelims 2023 question paper with you. The basic idea being not to just give you the answers of what the questions were, but also to give you the context that why did they ask whatever they asked. So all those things and looking into the future, how exactly should we be prepared for 2024 and beyond is what we are going to discuss in that particular class. So, and apart from that, any doubts that you have, we'll discuss about all that. So, just to mention that if you have any doubts that you want to ask, please send us an email, doubts_science and technology with this subject matter, right? With this subject, whatever doubt you have, whichever chapter it is, or whether it is about a chapter or a strategy, about anything that you want to ask, all those things you can bring in tomorrow's class, right? So, this is basically what we are going to do in tomorrow's session. So, let's begin. Now, the first topic that we have today is Internet of Things. Now, when it comes to Internet of Things, first and foremost, what do we mean by Internet of Things? What is the context in today's world? Why do we need to learn about this? And what are the areas of application? What are the areas where we see that we could use Internet of Things in today's world? So, let's discuss all that. But to begin with, I want you to just look at this particular question. Just read this question. Take a minute, read this question. Please read this question, everyone who's joining right now. Please read this question. And please let me know when you're done reading. When you've read the question, please let me know. Okay, some of you are done. Should I even ask what the answer to this question should be? Anyone who has a doubt about what the answer should be? Yeah, so that's why I don't think that it's required that I launch the poll. Okay, just for fun, let me just give you 10 seconds to give the answer to this question. It will count in your leaderboard, so please mark the correct answer. Okay, so still 85% of you have given the correct answer, yet not 100%. We are in the chapter of, topic of Internet of Things. Why do you think the answer should be something else? Why would I give a question which is not related to Internet of Things? So answer, of course, is Internet of Things. And I just wanted to give you this question because this question itself is self-explanatory about what Internet of Things should be, right? That it explains exactly what Internet of Things is. But let's still go back and understand the various aspects of Internet of Things. So first and foremost, when we say Internet of Things, what do we mean by Internet of Things? So Internet means inter-network, meaning a network of interconnected things. What is things? Things in a manner you can say things here means electronic devices. The meaning of things here in this context is electronic devices. Right? So in this particular case, when it comes to Internet of Things, we basically mean an inter-network of electronic devices. So in a manner, we can say that this is an interlinking of a bunch of digital devices, appliances, vehicles, and almost all possible gadgets. So basically all the internet, all the electronic devices that can connect with one another via maybe internet, via any kind of connection, that will be called as Internet of Things. Now, what exactly do we see in Internet of Things, and how does it become important for us? So one example that we just saw in the question was about how in a daily luxurious life you could use Internet of Things, how Internet of Things can become a very important aspect of your luxurious life. But at the same time, when we look at the applications of Internet of Things, we see that there are multiple different ways when we can make the use of Internet of Things, where we can very easily use Internet of Things, right? So how exactly, if you look at all these application areas that have been mentioned here on your screen, so if you see, for health monitoring, we can make the use of Internet of Things for health monitoring. How exactly in health monitoring? A lot of, you know, that when it comes to health monitoring, especially in the intensive care units or the ICU, you might see that there are a lot of electronic devices, the medical equipments that are connected with the patient, which are constantly monitoring the health of the patient, constantly monitoring all the vitals of the patient. So all these things are where we see that Internet of Things can become very, very useful, because every second they can keep on monitoring all the vitals, and if there is anything noticeable, anything alarming, they could send the information to the doctor. The doctors, or let's say the healthcare facilities, electronic devices could be connected to each and every room's vitals, and they can very easily check what's happening in each and every room with each and every patient. So constant health monitoring can very easily be done with the help of Internet of Things. Similarly, we see that there are multiple different ways in which Internet of Things can become useful. So for example, when we are talking about smart city, we know that Government of India has a program of building so many smart cities in India. So in these smart cities also, let's say something like traffic management can be done very easily with the help of Internet of Things, or even energy optimization in the entire city level, how to exactly save energy from one place to another. All those areas, all those things can also be handled with the help of Internet of Things. Similarly, in building smart homes, the example that we saw in the question, that's the question about building smart homes. So that's why we see that there are multiple different things, and the number of applications that we can think of goes beyond what we can just see in our daily lives. Because what happens is that everywhere, wherever you have a chance of having certain electronic devices connected together, and all these electronic devices communicating with one another to bring out the best of those applications, we see that Internet of Things can be very, very useful in doing all those things. So that's why whether it is agriculture, whether it is infrastructure, whether it is anything related to wherever electronic devices are working, we'll see that Internet of Things can become very, very useful in all these cases. Now, owing to all these applications, we see that today India has been working on implementing Internet of Things in a lot of various ways. For example, the Government of India a couple of years back decided to set up an Internet of Things based industry and invest up to $15 billion in this particular segment. At the same time, for all the initial research and development that needs to happen in this particular field, a grant of separately a grant of rupees 18 crore also has been assigned to Internet of Things. Then at the same time, for all the small industries, all the MSMEs, they're also every MSME that is using Internet of Things in their applications, they're also being offered up to rupees 6 lakhs per enterprise per annum. So that's why we see that now the investments have begun, not only by certain companies for their own private businesses, but also by the government of India for all the applications where Internet of Things can become a reality. Then when it comes to the other aspects, we see that already it has started to become a part of BTech and MTech courses, and also in PhD courses, we see that there are people who are taking up new topics related to Internet of Things. At the same time, the government also has been trying to make it as a part of Digital India Mission, and that's why it is going to play a major role there, because it can get a very important site from everywhere when it comes to, let's say, being included in something like a Digital India Mission. Then in the National Digital Communications Policy also, we see that technology like Internet of Things or technology like even 5G or peer-to-peer communication and all these, they all have been included in the National Digital Communication Policy. So that also helps. And then after that, slowly and steadily, we have started taking some strides. For example, the very first example was almost 5 years ago when the first Internet of Things based airport was inaugurated by our Prime Minister in Sikkim. Now, this airport basically acts as an early warning system. Early warning system against earthquakes. So this has been established as an early warning system against earthquakes in Sikkim, near Gangtok. So that's why we see that this is how we see that there are these steps that are being taken now in India, and that shows the seriousness that the government also has been showing in this particular scenario. Now, overall, although there are all these applications and there are all these steps that are being taken by the government, but still we see that there are certain limitations that we have right now. So looking at the limitations, first and foremost, we understand that the initial setup cost could be high. In this particular case, the initial setup cost could be high. It can lead to a lot of job losses because ultimately these all devices are being managed in a manner that you don't need an intervention from a person. So everything that a person might have done, you'll see that all those things can be done by machines. So that also means that it will lead to a lot of loss of employment opportunities, because we'll see that a lot of automation can happen in the industries. Because when it comes to Internet of Things coupled with AI and coupled with robotics, we'll see that these things will very easily become something that can lead to a lot of jobs being lost, especially in the areas where you do not have a skill requirement, but rather something which is a part of the assembly. So in all these cases, we might see that people who are employed, they can very easily lose their jobs. So that's why we have to be very concerned about these kind of issues as well. Then there are concerns regarding digital surveillance. The example that we saw in the question, that example basically talks about how digital surveillance can also happen in all these areas. That very easily what might happen is that every device that you're connected with, all these devices can keep on collecting your information, and it will keep on sending it back to the company. And now this company can use it in their own way. The company can use it. For example, let's say you're currently also there are your smartwatches. You already, for example, your smartwatches and your mobile phone, they might be connected. Correct? Your laptop also might be connected in some way with your mobile phone or your smartwatches, etc. Your Bluetooth devices also. Let's say if you have a Bluetooth headset or a earphone, that probably is also connected to your mobile phone and smartwatches, etc. So there are all these devices that we are already connecting with at a very trivial level. This is nothing but Internet of Things. So now in all these cases, whatever you are doing, each and every activity is also being recorded. That smartwatch, for example, might be recording your heart rate or maybe your number of steps per day and all these things that they keep on recording all the time. So now all these things, even if let's say the company that is collecting these information, let's say the company is not selling it off to anyone. Okay, let's assume that it's not going to use it to sell it to somebody else or something like that. But even then a possibility lies that they will use it for their own purpose. Now they haven't taken your consent here. They've not taken a consent that okay, fine, I'm going to use your data in this way or that way. It's just that they're using it without telling you. So all these kind of things will also get enhanced when it comes to more number of such devices and all the IoT-based devices that we might have in a smart house. So that also is a problem. Then right now one of the limitations is also the reliability of the sensors. We discussed this in robotics as well. That in robots you have these sensors, and these sensors will be in contact with the external environment, and depending on the information that they collect from the external environment, they can basically give out. They can basically work on anything, or they can give the information to the controller, and accordingly you might see that work. But at the same time, reliability of sensors is very, very crucial, because we see that the sensors may not be working fine. All right, the sensors may not be working fine, and that's why they may not pass on the correct, precise information to the controller, and hence they might not be able to interact with one another very nicely. So that becomes one of the key challenges that we have right now, that we need to have sensors which are very, very reliable. That is an issue that we have in Internet of Things. It's the same issue that we also have in robotics. Then high power consumption. This is also one of the issues, that because the number of devices are increasing, obviously the power consumption of all these devices will also be higher. So overall, you can say the burden of power requirement on the entire world will start to increase. So that is also one of the issues. Then lack of international standardization can lead to compatibility issues. Suppose that you are using 5 devices in your home, and all these 5 devices, they are coming from different manufacturers based out of different countries. One made in India, one may be made in China, one may be made in US, one made in Korea, and so on. So in what happens in these cases is that every country might be using their own standardization and not a standardization which is applicable everywhere in the world. So then in that case, these there can be small issues in the interaction between all these devices. So that also can become one of the challenges that we might see in these kind of issues. And then lack of skilled resources to maintain and run such systems, because these are new concepts, these are areas which are fairly new for us, and we haven't been using this for a very long time. So we do not have a lot of people, a lot of resources who know how to use Internet of Things. So that also is one of the limitations that we have in the current scenario. So this is what Internet of Things is. For those of you who joined it late, this is the question that we have started with. When the alarm of your smartphone rings in the morning, you wake up and tap it to stop the alarm, which causes your geyser to be switched on automatically. The smart mirror in your bathroom shows the day's weather and also indicates the level of water in your overhead tank. After you take some groceries from your refrigerator for making breakfast, it recognizes the shortage of stock in it and places an order for the supply of fresh grocery items. When you step out of your house and lock the door, all the lights, fans, geysers, and AC machines get switched off automatically. On your way to office, your car warns you about traffic congestion ahead and suggests an alternate route. And if you are late for a meeting, it sends a message to your office accordingly. In the context of emerging communication technologies, which of the following terms best applies to the above scenario? So this basically is about Internet of Things, where all your devices, they are connected to one another. All these devices, they are connected to one another, and that's why we see that this is an example of our dependence that will start creating on Internet of Things. So each and every one of these devices, they are connected to one another, and that's why we are saying that this is an example of Internet of Things. Fun fact about this question is that this was an exact question that I had given in the class just before the examination. I was taking a prelim special class just before your prelims examination, I think in 2018, and I had taken the exact same question. So for some reason, they also asked the exact same question. So either both of us had the same source, or maybe they were watching. One of the two possibilities. Yeah. So this is about Internet of Things. Next, very, very important technology is blockchain technology. Now, when it comes to blockchain technology, this is again a very, very crucial technology that we see today, and there are a lot of different applications where blockchain technology is being used. But at the same time, although there are multiple different ways, there are multiple different areas where they are being used, but they have been popularized by cryptocurrencies that have made blockchain technology very popular. Now, when it comes to blockchain technology, understand what exactly we mean by blockchain technology. So first and foremost, you have two words here: block and chain. So why exactly this has been named as blockchain technology? Because we have here blocks of data. Right? We have here blocks of data, and these blocks of data are connected via chains. So these are blocks, and these are chains. So blocks and chains, and that's why we are saying that it's a blockchain technology. Now, what exactly we see this blockchain technology doing? It is a decentralized distributed ledger that records the provenance of a digital asset, and that's why it is also called as digital ledger technology. Now, when it comes to blockchain technology, what we see them working, how we see them working is that, let's say in case of cryptocurrencies, this is basically how they would work. That first there is a user who requests for a transaction that, let's say I am about to send money to somebody. Let's say I'm sending my brother some money. So then I would initiate this transaction. As soon as I initiate the transaction, a block will be created which represents this transaction. So suppose that this block has 1 Bitcoin. So this 1 Bitcoin that I have in this block, now this basically is being sent via this blockchain. All right, this is being sent via this blockchain now what happens is that this block will be broadcasted. This block will be broadcasted to all the nodes in the network. So it goes to all these nodes in the network, and once it goes to the nodes in this network, we see that this is where the nodes will validate the transaction. All right, they will validate the block and the transaction, and once the nodes have validated the transaction, this is where the block will be added to the blockchain, and hence this transaction will be executed. So this is how we basically see the current scenario. This is how exactly we see the working of a blockchain technology in terms of any cryptocurrency, like let's say something like a cryptocurrency or anything like a Bitcoin. So it basically works in this manner. Now there are aspects of things that we see here on this particular screen that become very, very crucial. That today when we are saying that blockchain technology is being used by cryptocurrencies, there is a reason why they are using it. Why it has become so popular, not only in using cryptocurrencies that various companies are doing, or at the same time various different aspects of different works and different applications as well that comes through blockchain technology. So why is blockchain technology so popular today? Why is this blockchain technology so much being talked about in today's world? We need to understand that first. How we say that it's a very secure system, we say that it's a very transparent system. So how this security, how this transparency, all these kind of properties that we have, the advantages that we have with blockchain technology, how exactly does it come? What are the various aspects? So that's something that we should understand from the perspective of the blockchain technology. First, the safety thing that we are looking at, the safety and security, and at the same time, a very important aspect here is also transparency. So there are two things, especially that become important apart from all these properties that have been listed here on your board. We need to understand why exactly it is so popular, or why exactly it is considered to be so safe and secure. Now, overall, when it comes to its safety and security, understand the basic working of blockchain. That first and foremost, we are talking about this block, correct? We're saying that this block, as a transaction, this block will be created, and this block will go to certain nodes, and then after that, it will be validated, and then after that, it will be added to the blockchain. So this is entire thing that is happening. So what exactly do we mean by this block? What is this node? What is this validation? So we just need to understand all these so that we can get the basics of blockchain technology, right? So let's say if we are talking about this, let me take a blank slide here. So there are three aspects of this technology that we need to understand. First, from the perspective of the block. How does it become so safe and secure? First, from the perspective of the block. Now, when it comes to the block, what exactly is this block? This block is where we have, so block, first from the perspective of the block. So first thing is, when it comes to the block represents a digital asset. Right? Block represents a digital asset. Now, when I say a digital asset, the meaning of digital asset is anything that can be transferred digitally. So, for example, cryptocurrency is one popular example. But even if you're sending a very small PDF file, right? Let's say somebody has asked you for the notes of this classroom, the PDF of this classroom, and you send it, let's say, to that person. You can send that with the help of blockchain. You can take the help of blockchain and send it instead of sending it directly through WhatsApp or sending it directly through an email. You can send it through blockchain as well. So that is called as a digital asset. So that's an example could be anything. Example could be a PDF file, maybe a video, maybe a music file. So it could be anything, right? It could be anything, or it could be, let's say, a cryptocurrency. So any kind of digital asset, or anything that can be sent digitally, all these things will be considered as a part of the block. So that is what the block would have. Now, one thing that we see is that every block is encrypted. Every block is individually encrypted. Now, this encryption that we are talking about, there is a very important part of this encryption, and this is with regards to the block addresses. Every block will be represented by a certain address, all right? And this address is called as hash. This is called as the hash of the block. Now, this block address contains all the information about the block, and at the same time, it is also encrypted. So, every block has its own address called as hash. Right? Now, when it comes to this hash, so just understand how things work in this particular case. Let's say there is a blockchain like this. Suppose that we have a blockchain like this. Now, in this particular blockchain, what we'll see is that each and every block will have its own address, and all these addresses are also connected. So, for example, let's say if the block address of this block is A, then the block address of this block might be AB, and block address of this block might be ABC. So, do you see how these are connected? Correct? That the second one is connected to the first block, the third address is connected to the first and second, and at the same time, not only the fact that they are connected to one another, they are also timestamped. So, meaning that whenever the transaction has happened. So, for example, let's say the transaction has happened at 7 a.m. in the morning at on 11th of September 2023. So, that date and time will be noted on the block address itself. So, for example, this might say that this happened at 7 a.m. Let's say this happened at 7:30 a.m. and let's say this happened at 8:30 a.m. So the times are also noted. Now, why this is important? Two aspects of it: that all the blocks, all the block addresses are connected to one another, and that all the block addresses are also timestamped. So why exactly these two are important? Because of these two properties, what then happens is that if there is something that somebody tries to do in any one of the blocks, then everybody would come to know. Everybody would come to know that this is something that is happening. So let's say somebody comes at 9 a.m. and tries to hack into the second block. So as soon as somebody tries to modify anything or let's say do something with the block, this time will change. This time will change to 9 o'clock. So now how does it look? It looks like that first block was created at 7, second at 9, and then third at 8:30. That's not possible. That would be like traveling back in time and then making certain changes. So, right, so that's why it means simply it would notify everyone that this is something that is happening. Very quickly it will be known by everybody in the system that somebody tried to hack into the system. So that is why block address is being connected, and every block address having the timestamp is a very, very important property. So that's why this becomes very crucial that hash of the blocks are interconnected and timestamped. Okay, so this also becomes a very, very important property. And then there is another property, that is that once you have added a block, blocks once added can't be removed. What does it mean? That once you have added the block to the blockchain, you cannot remove that block. All right. So that's why, let's say, for example, how an email works. What happens in an email? That suppose that you have written an email to somebody, then that person also replies on that email. Once that person has replied on that email, let's say you also reply on that email, or let's say there are 5 people, and all these people can also see that email, but nobody can delete any email. Let's say you have written something which is wrong. You have given a wrong information in that email. So even if you have given a wrong information in the email, even then, it's not that you can delete that email. Correct? You'll have to correct that information with another email. That you will write another email and you'll say that whatever I did in the previous email, that's wrong. This is the correct information. So you cannot delete it. You can delete it from your inbox if you want, but that does not delete it from everywhere. It will be like an ostrich hiding their head in the sand. So even if you delete that email, it does not matter unless you can go to each and every person's email ID and delete that from their emails or from their inboxes. Correct? So that same thing happens here as well. That blocks, once they have been added to the blockchain, they cannot be removed. So even if you have done a wrong transaction, for example, then you'll have to create another block with the correct transaction. Until then, that transaction will remain as it is. So that's why we see that it becomes a very, very crucial part of the security that we are providing to the blockchain. So that's why this blockchain technology, because of all these things that we have, we see that it makes it very, very secure. Now coming to the second aspect, and the second aspect here is about the nodes. The second important part of the security is through the nodes. Now, what is the role of nodes? What do we mean by nodes first and foremost? What do we mean by nodes? And what is the role of nodes? How do the nodes make this a very secure and a transparent system? So nodes are basically users who are anonymous, users about whom you don't have any information. And these users, they have to validate the transactions. So what happens is that as soon as, let's say, when I started the transaction, it was broadcasted. This is what was written here, that the transaction is broadcasted to all the nodes in the network. So all the nodes basically get a copy of this transaction. Now all these nodes, they have to validate the transaction. And as they validate the transaction, only when they validate the transaction, this block will be added to the blockchain. Now, first and foremost, what is this validation? What is this validation? That, let's say it's like that a block has come to you, you will validate it and the block will be added. Two questions. First, how do you validate the transaction? And second, a more philosophical one, why would you validate the transaction? Why would you even validate the transaction? Correct? So first is why. The answer to why is you are being paid. For each and every correct validation that you do, you will get some amount of money. So obviously you will validate. So now, does it mean that every one of us should just become a node in a blockchain network so that very easily we can keep on just earning some money? Is that the case? The answer is no. Validation is not that easy. It's not that it's a simple yes and no. That a screen pops up in your, let's say a chat pops up on your screen which says, do you want to validate the transaction? And you say yes, and the validation is done, and you get the money. Unfortunately, things are not that simple. For all these transactions, for all these validations, the nodes have to solve a complex mathematical problem. So I know half of you lost the interest as soon as I mentioned complex mathematical problem. So this is basically what happens, and that's why becoming a node is not that easy. I mean, earning money is never easy. You have to do something good to earn that money, and same goes here as well when it comes to the nodes. That you will have to do all this. So first and foremost, who are the nodes? Nodes are anonymous users on the blockchain network. Anonymous users on the blockchain network. They validate the transactions only when all participating nodes validate the transaction it can be executed. So this is a very, very important point. All right, this is a very, very important point. So it's not about that one node would validate or a couple of nodes would validate and the validation will be done. No, every node that is participating. So for example, let's say there is a blockchain network in which there are 100 nodes. Out of these 100 nodes, there are 60 which are participating. So these 60, all 60 of them, they have to validate the transaction. Only then the transaction can be completed. If there is even a single node that invalidates the transaction will not go further. right? The transaction cannot be executed even if there is one single node that has invalidated the transaction. It's just like how the UN Security Council works, that all the permanent members, unless if there is somebody who uses their veto power, then it just nullifies whatever decisions are being taken. So something similar happens here also, that each and every node has a veto power, and if at all it is possible for them, if at all they invalidate the transaction, the transaction will not go further. So that's why only when all the participating nodes validate the transaction, it can be executed. Now, for every correct validation, the nodes would receive a reward, or let's say a payment. Now, there is one term that you might have heard. This is called as crypto mining. If you've heard have you heard the term crypto mining? Anyone? Yeah, because you've already written this, correct? So yes, a lot of you have heard of it. So for those of you who haven't heard the term crypto mining, so crypto mining is when a new node, when all the nodes validate a transaction and a new cryptocurrency, or let's say a new Bitcoin or anything new, a digital currency or a digital asset is added to the blockchain. So whenever this new addition happens, this is called as crypto mining, and that's why the crypto miners, there will be all these miners. The nodes are also called as miners because they would keep on generating new cryptocurrencies, and for every new cryptocurrency that they generate, they would be paid a certain amount. So that's why we say that it is called as crypto mining. So when a new block is added to the blockchain, it is called crypto mining. Correct? It is called as crypto mining in terms of cryptocurrencies. So this is basically what we see in terms of cryptocurrencies. So now with the nodes, what we are saying is that they are completely anonymous, meaning that you don't know their name, mobile phone numbers, email IDs, Aadhaar card number, nothing. You don't even know where they are sitting, whether they are in India or they are in Pakistan, they are in Australia, you don't know. You just know that these are nodes who are there in the system, and they have just one job, that they have to validate the transaction. To validate the transaction, they have to solve a complex mathematical problem. So when it comes to complex mathematical problem, it does not mean that there is a high order mathematics that is involved here. It just means that the computation is very vast, and it's very unique, and it's very big. So that's why it becomes complex for anyone, and normal computers cannot do it. Normal calculators cannot do it. You have to have very good high-end computer systems to run these kind of calculations. So that's why the nodes, before becoming nodes, they also have to invest a lot in having these kind of systems. So that's why they'll need high-end computer systems to make these calculations. Otherwise, it's not that you can simply do it on your mobile phone or on your computer. You cannot. You'll have to buy those special computers, and only then this is possible. So that's why even being a node is not that easy. So because you would need all these high-end systems, these computers, they would also need a lot of energy. So consumption of energy increases, your electricity bill increases. These the systems already are high-end systems. You have already spent a lot of money in buying these systems. So there are all these issues that the nodes would have. So only if the nodes think that they can, even after spending all this money, they can still generate more money, then only they would want to become a node. Otherwise, it will be something that will be a complete loss for them, if at all they don't know how to become a node properly or how to earn that money from being nodes. So that's why being a node is not only about just a tick mark and validation. There are a lot of complexities for anyone who wants to become the node. Now, the third aspect of security is from the perspective of the user itself. Now, when it comes to the user also is completely anonymous, first and foremost. The users are also completely anonymous. They have a public and a private key. They have a public and private key to execute the transactions. To execute the transactions, they have a public and a private key. It's just like a bank locker. So if you, let's say, if you own a locker in the bank, you might see that there are two keys that you have for the locker. One key that belongs to you, the second key that belongs to the bank. So unless both the keys are used, the bank locker cannot be opened. Something similar happens to the users as well. Each and every user, they will have their own private key, plus there will be a public key of that blockchain that they are using. So unless both the keys are used together, they cannot execute the transaction. So that's why we see that there are all these things that we have. So from the perspective of the blocks, the nodes, and so this is one aspect of all the security and transparency that is added. That becomes very, very crucial from the perspective of the block. Second is from the perspective of the nodes and how the nodes are very, very crucial to run this system. And then from the perspective of the blocks, that even from the users, that even the users, they are also completely anonymous, and they are also participating with the transparency. Now in all these cases, what we also see is that all the nodes, they also have they have a view of each and every transaction that is happening. So it's just like, let's say, a shared Google sheet, a shared Excel sheet, etc., where in that shared Google sheet, there is a view access that has been given to everyone. So you can view what's happening there. You cannot really do anything. You cannot make anything happen in this. You cannot change or modify anything. You can just see. So here also they can see each and every transaction. And if they see that there is any fraudulent transaction, any wrong transaction happening, something which is let's say which is not entirely a correct transaction, they can flag it. They can flag it, and they can end that transaction, and they can stop the transaction from going further. So that's why there are all these cases. There are all these aspects of blockchain that make it very, very secure. So that's why if you look at all these properties, that we are saying that it's a distributed system, meaning that all the network participants, they have a copy of the ledger for complete transparency. Right? So that's what we are saying, that all the nodes basically know what's happening on a real-time basis in each and every transaction. Then we are saying that it is immutable. So immutable meaning this point that we discussed, that blocks that have been added once, they cannot be removed. The fifth point that we discussed here, the blocks once added, they cannot be removed. This is called as immutability. So that's why validity records are irreversible and cannot be changed. Then there are timestamp. We discussed about this as well, that there is a timestamp for each and every block. Then this is a unanimous system. Unanimous meaning that all the nodes have to validate. Unless all the nodes validate, the transaction cannot be completed. So that is what it means by being unanimous. Then it is anonymous. We discussed this as well, that all the nodes are completely anonymous, all the users are completely anonymous, and that's why nobody knows anything about anyone. So that's why it becomes a completely transparent system, and a system that will run on its own. Because I'm not going to favor anyone, I'm not going to go against anyone. It's just like, let's say for me in this classroom, that I just know your names. I don't know anyone personally. Even these names that I have here in the chat box, I don't know whether these are correct names or not. So I know nothing about you. So I would not have any bias for anyone. Correct? I not have any bias in this classroom. Whatever lectures I'm delivering, it's for everyone. Right? So something here also happens simultaneously. What we see is that because everyone is anonymous, nobody knows anyone. Everybody here is for their own good, for their own benefit. That's why it becomes a completely transparent and trustless system. So that's why we say that it is a trustless system. Trustless. So we are not saying that it's a trustworthy system, or we are not saying that it should not be trusted. We're just saying that trustless system, meaning that trust is not even a factor, because everyone, whatever they are doing, it helps them, plus it helps the block, and nobody has any favors for anyone, nobody has anything against anyone else. So this can be a perfect case of democracy. Right? Then it is a secured system because everything is individually encrypted. That's something that we discussed, and it is programmable. Now this is also very, very important property. It is programmable, meaning that you can use it for various different purposes, and it's not necessary that you use all the properties that we discussed at the same time. You can pick and choose. You do not need anonymity. You don't keep that anonymity. For example, let's say if a company is implementing blockchain technology for themselves, right, for their own company, for their own employees, then obviously they wouldn't want that everybody is anonymous there. So they would take away the property of being anonymous. So everything, whatever you have, you can pick and choose. Not all the properties are necessary to be used at the same time. Right? Not everything has to be implemented at the same time. It's something that you can choose, something that you can decide that you want this, you don't want that, you can do that. So that's why it is called as being programmable. Right? So that's why we see that in contracts also it can be used. And as I told you that even if you want to send a PDF file also over a blockchain, you can do that. So you can do whatever you want. You can use whichever properties you want of the blockchain. Now, when it comes to some of the issues that we have with blockchain, one has been transaction cost, especially in the case of cryptocurrencies. For each and every transaction, there's a small cost to be paid. Excessive use of energy. This is basically because of the nodes. Because of the nodes using high power draining computers. Then complexity also becomes a challenge. That whatever we have discussed, this is just a surface level of what exactly goes behind the scenes. So there are a lot of complexities, and it's not easy for everyone to just implement a blockchain for their own good. Then there is one problem of storage. Now, why is the problem of storage? Because what we said is that blocks once added, they cannot be removed. Correct? Why this? Because blocks once added can't be removed. So this also becomes a challenge. Right? This also becomes a challenge that once you've added the block, you cannot remove the block. So over a period of time, the amount of space that you're taking up will keep on increasing. So that storage issue also becomes a challenge. But there are ways in which this storage issue can be handled. There are archives, for example, that can be created, and we can channelize the storage. But ultimately, storage problem, especially for the nodes, it can become a huge task. Now, when it comes to the use of blockchain, what we have seen is that cryptocurrency has been one of the ways in which we have been using the blockchain technology. The reason why blockchain technology became so famous and not being seen only as something that is used as a security thing, we see that it was cryptocurrencies, and especially Bitcoin. Bitcoin was, you can say, the first cryptocurrency to popularize this blockchain technology because it functions on blockchain. So now cryptocurrencies, they become an alternate currency in a manner different from the fiat money that we have been using for our transactions. But we do see that in cryptocurrencies, because of this kind of anonymity and the transactions that can be done everywhere, the fact that it would also grow in its numbers, and we might see that it might grow in its value as well. We see that cryptocurrency not being used, but even cryptocurrencies are being traded. If you know, just like how the trading happens in the stock markets, similarly, trading of the cryptocurrencies are also done. So, for example, let's say the value of a Bitcoin, value of one Bitcoin will also keep on rising and falling. Do you know what is the current cost of one Bitcoin? How much does one Bitcoin cost right now? What is the approximate value? Anyone? Anyone who knows how much is one Bitcoin worth in Indian rupee? Yeah, almost 20 lakhs. That's correct. Almost right now, it's almost 21 lakhs if I'm not wrong. It's almost rupees 21 lakhs. So, okay, 21,32,444. Okay, this is the current value as somebody has mentioned. So almost, as I told you, that almost 21 lakh rupees is one Bitcoin worth. So now somebody who trades in Bitcoin. So suppose, for example, you have invested in one Bitcoin, then the value of this one Bitcoin is 21 lakhs today. It might rise, it might fall, depends on countries accepting, countries not accepting, some government saying something for or against this Bitcoin. So for example, let's say almost 6 to 9 months back, this value was almost 18 lakh rupees if I'm not wrong. So it has grown by almost 3 lakhs. It actually had gone up to 23, 24 lakhs a couple of months back, and it has then from there, it has fallen to 21 lakhs. So this kind of fluctuation keeps on happening. And that's why people keep on losing their money on cryptocurrencies. That thinking that this is going to grow, people always have thought that this is going to grow, and possibility is yes that it might grow further. But the fact also is, if you know, do you know what the cost was almost 2-3 years back when bitcoins were doing very well? So there are people who also invested when bitcoins were worth more than 50 lakh rupees. One Bitcoin was, I think, 54, 55 lakhs if I'm not wrong. One Bitcoin. So, and then many people invested thinking that this is just going to grow from 55 lakhs, it's just going to go further. And from there on, the value has just depreciated by more than 50%. So that's why these kind of issues are there in case of cryptocurrency trading. So that's why stay away from trading unless you know the market very well. Otherwise, this is what is going to happen with you, something that you see on your screen. Right? So in case of cryptocurrencies, it is being used. Apart from that, we also see that it can be used in NFTs. NFT, it is non-fungible tokens. Non-fungible tokens, NFT. Now, NFT also all of a sudden had become very popular a couple of years back, especially in 2021. Then when all of a sudden NFTs were being created for a lot of different artworks and paintings, etc. A lot of personal belongings of certain celebrities, for example, NFTs were being created out of it, and these NFTs were being sold via blockchain. Now, these NFTs, they basically are like, you can say, like a ticket. So, for example, if you are traveling through a train or a bus or let's say a flight, you might see that there is a ticket that is given to every one of us. Right? All these tickets look very similar. They look very similar, but all these tickets are different. For example, my ticket will have my name and my seat number, etc. on my ticket, and yours will have that as well. They look similar, but these are specific. These are unique. So similarly, we see that these are similar to what NFTs are. That for each and every, for example, let's say if there is a painter, let's say a very, very famous painter in the world who has created one painting, and it's a very special edition. It has just 50 copies. He's just going to sell 50 copies of that painting. So that those 50 copies, each and every one of those 50 copies, they will have a ticket associated with it, a non-fungible token associated with it. So when I am buying that painting, I will have that token. So now let's say I have bought it for 10 lakh rupees. It's a very famous painter, a very famous painting. It costs rupees 10 lakh for me. So I bought that painting for rupees 10 lakh. So now I have a token. I have a token for that painting that I bought. Now why do I buy this? Why do I keep this token? Because tomorrow, because this is a very special edition and only limited number of copies were produced. So this might become even more. This might even create more demand in the market tomorrow. That tomorrow a lot of people might want to buy that particular painting. So maybe tomorrow I can sell it for rupees 20 lakhs. So that one token that I have today, which is worth 10 lakh rupees, tomorrow it might have a value of rupees 20 lakhs. So thinking that, keeping that in mind, I might want to just keep that token with me. And that is what actually happened in case of NFTs a couple of years back. Thinking about this, a lot of very weird things were just sold via NFTs, which could have made no sense, but people thought that it's going to generate more value in the market, but it completely depreciated because it was not very important. A lot of things were not very important. But it's not only about artwork and collectibles, music, gaming, etc. Even in keeping records, we can make the use of NFTs. In supply chain tracking, in property owners tracking, in health records, monitoring, etc. In all these cases also, we can make the use of NFTs. That each and every bit of information can be exchanged with the help of an NFT. So that's why there also it can become very, very useful. Look at this question. This was asked in your paper, in your 2016 paper. This was asked. Please read the question and then I'll launch the poll for you. Please mark your answers. So 8% of you are marked A, 56% B, 13% C, and 22% D. So B, yes, 56% of you are correct. With reference to bitcoins, sometimes seen in the news, which of the following statements is or are correct? First is bitcoins are tracked by the central banks of the country. That is the biggest challenge. That banks cannot track it. There's a reason why it has been banned and no country is using it. No country is allowing the complete use of bitcoins is because of this. That, for example, a body like RBI would never know what's happening, what kind of transactions are happening through bitcoins. So that's why even if there are some illegal transactions happening, let's say drug transactions, it is said that the most amount of money flowing in the Bitcoin market today is through drug transactions. It's because of drug transactions. So that's why, let's say somebody is buying some drugs from somebody, they can pay them via bitcoins and nobody would know. No authority would come to know. And that is the biggest challenge why the governments are so reluctant in letting anyone use bitcoins or any kind of cryptocurrency for that matter. Only the trading has been allowed, the use hasn't been allowed. And use hasn't been allowed because of this very factor, that it can be used for anything, any kind of activity, because you are completely anonymous. That's why we are saying it's completely anonymous. So if it is completely anonymous, nobody can track you. So that's why first is wrong. Anyone with a Bitcoin address can send and receive bitcoins from anyone else with a Bitcoin address. This is correct. We discussed about the public and the private keys. We discussed about the public and private keys, and this is basically what it is. Online payments can be sent without either side knowing the identity of the other. So this is basically also correct. We discussed about this as well, that the users are also completely anonymous. So 2 and 3. So correct answer will be 2 and 3 only. Now we come to a very, very important topic again, and this is about supercomputers. Now, when it comes to supercomputers, first and foremost, why are we calling them as supercomputers first? And second, where do we use these supercomputers? So first and foremost, why we are saying that it's a supercomputer? Because this is a computer that can perform at or near the current highest operational rates for any computer. So that is why these are being called as supercomputers, because their operational rates are among the highest that you have for any computer right now that exists. Now, in case of supercomputers, what we see is that supercomputers have been the number of supercomputers has been growing in the world, and not only in the world. We see that in India also there is a national supercomputing mission that we have, and as a part of this national supercomputing mission, we see that we have been using these supercomputers a lot. So, for example, when it comes to supercomputers, we are saying that these are the highest, the computers operating at current possible highest operating speeds. So, in this particular sense, these become very, very important for certain applications also for us. So, for example, let's say when it comes to the use of supercomputers, we see that in case of supercomputers, these are special purpose computers. We call them as special purpose computers. All right, we call them as special purpose computers. So now, why special purpose computers? Because they would have a specific purpose. So for example, there is a supercomputer that we might design for genetic studies. So that supercomputer will only do genetic studies. Then there can be one for climate change studies. So that can only do climate change studies. One can be for something, let's say, related to material engineering. So that can only do material engineering. So that's why these are special purpose computers, as opposed to our normal computers. Because our normal computers are what? They can do everything. We can watch the lectures on that computer. We can do the office work on that computer. We can play games. We can watch movies. We can do everything in that one computer. So that's why our computers, these are called as general purpose computers. And when it comes to supercomputers, these are special purpose or specific purpose computers, because they can do only the job for them they have been constructed. But they can do that job at a speed that is unimaginable. That is way beyond the normal computation speeds that we use in our normal computers. So that's why if you look at how supercomputers look, they do not look like the computer or the laptop that we carry around. Right? This is an example of a supercomputer. So that's why you cannot say that it looks like it's a simple machine. It basically has a lot of processing power, and that's why you, instead of one system, you have a room that basically is the entire system. So that's why in this particular scenario, this is what we see. Now the speeds that we are saying, that the speeds are almost the highest that we can think of, and it is mentioned, or it is measured in terms of petaflops. Now, in case of petaflops, when we say petaflops, understand the meaning of the term petaflops. So flops here means floating point operations per second. That's why flops, floating point operations per second. So floating point operations are the normal operations like addition, subtraction, division, etc. They can be called as floating point operations. Now, peta, what is peta? Or rather, how much is peta? Everybody is saying, Amit, your answer is correct. Amit, you are correct. Janvi correct. Abhijit correct. Yeah. So see, Peter. So how do we start? We have kilo, we have mega, we have giga, we have tera, and then we have peta. So how much is kilo? It is 10 to the power of 3. Mega is 10 to the power of 6. Giga is 10 to the power of 9. Tera is 10 to the power 10. Sorry, 12. And peta is 10 to the power of 50. And then comes exa. If you just want to know, it is 10 to the power of 18. So this is basically how we are looking at. So when it comes to peta flops, peta means 10 to the power of 15, meaning one peta flop. What is then the meaning of one peta flop? One peta flop would mean 10 to the power of 15 calculations. 10 to the power of 15 calculations in 1 second. 10 to the power of 15 calculations in 1 second. That is basically what we mean by one petaflop, right? So right now the fastest supercomputer that we have, is having a speed of 1102 petaflops, meaning that it can do 1102 into 10 to the power of 15 calculations in 1 second. And the name of the supercomputer is Frontier, right? Name of the supercomputer is Frontier. So Frontier now has become the fastest supercomputer in the world. Now, as far as when it comes to, and apart from that, so now for the last 2 years, it has held its position 1. Before this, there was Fugaku. Now Fugaku has become the second fastest with an operational speed of 443 petaflops. So that's why this is where we see that now Frontier supercomputer has become the fastest supercomputer in the world. Now when it comes to India, in India we first started our supercomputer program in 1987, and then after that we see that we had built the Center for Development of Advanced Computing, or CDAC. So CDAC became the premier research and development organization in India, and right now it functions under the Ministry of Electronics and Information Technology. So as a part of it, it basically works there. And right now until 2022, a total of 15 supercomputers have been developed in India. Currently, when it comes to the Indian supercomputers, until last year, the fastest speed that we had seen was up to 6 petaflops. But this year, we see that now we have been able to do better than that, and we have Airavat. Sorry, we have Airavat. Now, this Airavat that we have, or Param Airavat as it is called, this Airavat has now become India's fastest supercomputer, and it has shown a speed of 13 petaflops. According to the newest, every year there is a global rank of fastest 500 supercomputers that is released. Last year, I think we were somewhere around 110th position. This year, we now have rank 75. So we were the fastest supercomputer that we had was ranked almost around 110 last year. This year we have come to rank 75, which is obviously a much better rank, and obviously we are also improving day by day. So overall, we see that we see a lot of improvement happening here, and there are a lot of steps also that are being taken by the government of India to ensure that we can have a better supercomputers and faster supercomputers in the coming days. So that's why, as a part of this national supercomputing mission, we see that today we have been working on supercomputers in India. Now, when it comes to the applications are pretty simple. Wherever you need very fast data processing, supercomputers can be used everywhere. So these are just some examples. Of where we can use supercomputers. We can use it in a different number of different ways. Wherever we need very fast data processing, we can make the use of supercomputers there. So that is what we have about supercomputers. Then a small topic, that is cloud computing. Now, cloud computing basically is when you are storing your information online, meaning that when the information, instead of being stored on your computers or on your mobile phones, when you are sending that information somewhere over the internet online, then in that case it is called as cloud computing. A very simple example is your Google Drive or OneDrive, or let's say any kind of storage, any kind of online storage that you might be using. So that becomes cloud computing. So with regards to cloud computing, what we see is that there are various benefits that we get. There are various ways in which we can make the use of cloud computing, and it makes overall it makes your job easier and faster. So for example, let's say there is a bulk of data that a company is using for its own purpose. Then in that case, the company cannot download that data on each and everyone's computer or each and everyone's laptop. That would first of all be very costly, and also it can also slow down the network. Also can pose some security issues because you do not know how that data might be used by the employee. So that's why, especially if the company is using some data that is very sensitive, it might want to protect it as much as possible. So that also is something that adds to the problem. So that's why we see that with the case of cloud computing, we are able to provide the computing services typically over the internet. So that is basically what is being done in case of cloud computing. So Google Drive is an example. Amazon has its own web service, and for example, a company like Amazon, which is known as the world's largest e-commerce company, one of the largest e-commerce companies in the world, e-commerce is not the most profitable business for them. The most profitable and the most revenue generating business is Amazon Web Services, and that Amazon Web Services is basically a cloud computing network, which a lot of companies around the world have been using. So that is, for example, let's say your own, all the data that you have on your VP app, or before we used to have the student portal, all these data also that we are giving you, it's through Amazon Web Services. So that's why Amazon Web Services is very, very crucial. Even the entire OTT platform like a Netflix, it runs on Amazon Web Services. So that's why these kind of web services or the cloud computing systems, they actually are very, very profitable and revenue generating businesses for these largest of the companies in the world. Now, the last topic for us is about quantum technologies. Today, what we have seen is that a lot of quantum technologies and a lot of things which are based on quantum technologies, they are surfacing. So we need to just understand the basics of what these quantum technologies are, because beyond that is way beyond what we can comprehend and understand. Because when it comes to quantum technologies, the use of quantum technologies, we are talking about technologies that would use quantum mechanics or quantum physics. Now, quantum physics or quantum mechanics, do you know what is quantum physics? What do we mean by quantum physics? What does quantum physics do? Quantum physics or quantum mechanics? What does it do? Where we study about matter properties in a very minuscule details. This is the last topic of this chapter. Use quantum bits, basically store data, study of matter and energy, atomic level physics, yes, that's correct. Particle study, yes. Understanding physics of microplastic particles, correct. Study at the atomic or subatomic level, that's correct. Study of matter through the most fundamental level. Yes, you can say that. So many of you have given correct answers here. So quantum physics or quantum mechanics is about the small particles, about the very tiny atomic or subatomic level particles. Now, why are we talking about these specifically, separately? Why does it become a different branch of physics? The reason is that the properties that we see at this level are very different from the properties that we see at our level. So, for example, each and every physics property that applies to our level, it doesn't apply at the atomic level. It does not apply to the subatomic particles like electrons, protons, neutrons, etc. It does not apply there. So, compared to what we see, something called as the classical physics, it's very different from quantum physics. And it's not only different, but I would also say that it's very weird. It's very difficult to even understand and comprehend what's happening. And some of these properties that we see at the level of quantum mechanics or at the level of atomic or subatomic level, it's incomprehensible to say the least. So that's why this means that first time you study quantum mechanics and the thousandth time you study quantum mechanics, it's the same. And that's why very famously it was said by, I think it was Richard Feynman who had said it. I'm not sure. That what he had said is that anyone who says has understood quantum mechanics has not understood quantum mechanics. So this is a very famous quote in quantum mechanics. So a lot of these concepts are pretty weird concepts, but there are some fundamentals that we should know of. So there are these basic fundamentals that we should always understand, which work in quantum technologies. So first and foremost, there is wave particle duality. Now wave particle duality. Now what do we mean by wave particle duality? Anyone who recognizes this? Anyone who knows which movie it has been taken from? Anyone who knows about movies? Okay, Nagin is the film. That's correct. So the name of the film is Nagin. What happened in the film Nagin? Human snake combination. Ichhadhari Nagin. Yes. So in this particular movie, Sridevi, who played the Nagin, she could take two forms. She could have the human form. She could be in a snake form as well. So she could exist as at both. Same happens with the particles. Particles at the subatomic level. They can exist as particles. They can also exist as waves, which is very different, very weird to think of. That inside the atom, we count the number of electrons. Correct? We count the number of electrons. We counted the number of electrons, protons, etc. in nuclear technology, right? So we can count the number of electrons where they behave like a particle. But at the same time, they can also behave like a wave. They can also travel like a wave. So if you remember what we discussed in tunneling, the concept of tunneling, where particles can simply enter because of that wave behavior that they have. So that's why what we see is that particles such as electrons and photons, they exhibit the properties of both waves and particles at the same time. That's why this is one of the properties and very difficult to even think of. Just imagine that there is a person who actually exists like a Nag or a Nagin, where they can take a snake form and they can take a human form both at the same time. So that is something that we see at quantum level happening. That particles can behave like waves and waves can behave like particles. So that's why it is one of those concepts that is right now unimaginable for us at our level, but something that we can actually see at the level of particles. Then there is this concept of superposition. Now, superposition, what we say is that particles can exist in multiple states at the same time. So when we say multiple states at the same time, what is the meaning? The meaning is that let's say something like an electron can have multiple energy states at the same time, meaning that the same particle can have 10 joules of energy and 20 joules of energy and 30 joules of energy. Now, even that is not thinkable at our level. That how can it exist in various different states? So just imagine, let's say somebody like me who's taking a class right now in your classroom. You do not know where I am. You just know that this is a remote studio somewhere in the world, from where maybe not this world, maybe Mars. I'm taking a class from somewhere, correct? So for you, until you know where I am, until let's say you are with me in the classroom or maybe in the studio, you do not know where I am. And for you, I exist in multiple states. I'm existing on your personal screens wherever you are, correct? So that's why I could be with you in Delhi, in Mumbai, in wherever you are taking the class from. So that is why we do not know, and we know that there are multiple states in which these electrons can exist in, and that is called as the concept of superposition. So this film last year, it won the Oscar for the best film, right? Everything Everywhere All at Once. This was the film that won the Oscars last year, and the principal concept on which this film is based on is the principal concept of superposition. That all these characters who you have in this film, they could exist in various different parallel universes at the same time. So all these parallel universes are nothing but superposition, and they have actually shown the concept of superposition through this film. Then there is one more principle here, which is called as the uncertainty principle. Now, in case of uncertainty principle, this is where we say that it is impossible to simultaneously determine the exact position and momentum of a particle. That either you would know about the position of the particle or you would know about the speed of the particle. You cannot know about both the things at the same time. That's again something which is very weird to think of. That how something like this is possible. That we are saying that either this or that. You can't know about this. There's a very famous example that is taken here, and this example is of Schrodinger's cat. Schrodinger's cat, because Schrodinger was the one who had explained this uncertainty principle, and that's why it is taken. He would take this kind of an example of a cat in a box. So the example says that let's say you have a cat which is put in a box. Now you do something which might kill the cat, but you do not know whether it actually killed the cat or not. So for example, let's say I have this box. Inside the box somewhere there is this cat. I take a knife and I stab through the box. And if when I stab through the box, I do not know whether it hit the cat or not. If it hit the cat, cat probably died. If it did not hit the cat, thankfully maybe the cat is alive. So whether it is alive or whether it is dead, I do not know until I open the box, right? When I open the box, then only I know the state. When I open the box and I see that, okay, fine, I'm relieved that the cat is alive. Then I know the state of the cat to be alive. Otherwise, for me, until the time that I know, until the time I've opened the box, I do not know what state cat is in, right? So until then, it's just a probability that I know of. I just know probability that it might be dead, it might be alive. Same goes for all the electrons, or let's say any subatomic particle, that you cannot know the position of the electron or the speed of the electron both at the same time. If you know the speed with higher precision, then the probability of knowing the position is very low. And if you know the position with high accuracy, then the probability of knowing the speed or the momentum is very low. So this is something that the uncertainty principle says. Then we have the concept of entanglement. Now, the concept of entanglement is also a very weird concept, where we say that there are two particles that become correlated in such a way that the state of one particle affects the state of the other particle, even when they are separated by large distances. Now, even this is a concept that is again unthinkable for us. And apart from obviously the films, where in the films it has been shown, this is a property that was first predicted or rather seen by Albert Einstein. Now, Einstein basically had called this phenomena spooky action at distance. spooky action at distance. So for him, it was a spooky action, something which is very remarkable and unthinkable at the same time. That how exactly is it even possible that there are two particles which are completely at different positions, yet somehow their properties are connected, and all these properties, if I make any change in this particle also starts to show the same change. Something that we have seen in films like Judva. If at all somebody has seen this film, whether this one or there was a newer one also that released a few years back. So what we see in this particular film or any film where you have twin brothers, twin sisters, etc., what you see is that if something happens to one of them, the same thing happens to the other one as well. That if you slap one Salman Khan, the other Salman Khan also gets slapped. So that is something that we observe in that film, in this film, that whatever happens to one, the same thing happens to the other. So that is nothing but entanglement. That's the concept of quantum entanglement, which has been used very well in Indian movies, especially by the director David Dhawan. So one of the scientists in Bollywood, he's already used the concept of entanglement very well. So this is basically what we see. That the concept basically is nothing but in one line that these are two particles whose properties are just connected. How they're connected, you can't go there. Otherwise, it's impossible for these discussions to do in the classroom. But just remember in one line what's happening, right? That their properties are just connected. Then there is the concept of quantum tunneling that we had discussed in nanotechnology as well, where we discussed that the particle will be able to break the energy barrier and enter inside the surface. That it will be able to enter the material by breaking the energy barrier of that material. So that is called as quantum tunneling. That is the quantum concept of quantum tunneling. So where we see that the particles can pass through a potential barrier even when it does not have enough energy to overcome the barrier. So a film like this, where it has been actually portrayed, where we see that this character can just shrink and can enter inside anything. So that entering inside anything is nothing but tunneling, where the particles can enter inside. Otherwise, there is, the wall. You cannot just enter inside the wall. But in these kind of cases, we see that the particles can actually enter the wall and pass through the wall by breaking the energy barrier. So that's something which is again very unique and unthinkable at our level. That we cannot simply just pass through walls, right? We cannot, unless we are a ghost, we cannot. So, but in these cases, we see that these particles can actually pass through a barrier. So that passing through the barrier is called as quantum tunneling. So that's why we see that there are all these concepts. We do not know. You don't need to put a logic right now behind it. That how is it possible and why this is happening? Forget about all that. It's too complex of technology or science to even know of, unless somebody is very specialized in these branches who have done their BSc and MSc in physics. Only those people would barely understand what's happening. Otherwise, you cannot. So just in one line, just understand that okay, this is what is happening. That in superposition, we are just saying that particles can exist in multiple states. Done. Tunneling, particle can just enter inside the surface. Done. In entanglement, two particles can just be connected. How connected? Don't need to understand. Just that their properties can be connected. That is entanglement. Uncertainty principle. You can't know the speed and the position at the same time. Done. How? Why? No need to wonder about it. Wave particle duality. They can exist as wave. They can exist as a particle. No need to know why. No need to know how. Just that they can. So only just know this one line about all these properties. Because even if UPSC has to ask a question from here, they cannot ask beyond this one line. They cannot go beyond this one line. They will also stick to only this concept and nothing beyond that. So based on these quantum principles, we have something called as quantum computing. Now, in this case of quantum computing, this is a new kind of computing technique that the world right now has been trying to understand and trying to work with. And you can say that in certain cases, we have also succeeded in making a quantum computer. Now, what's special about quantum computer? A quantum computer will have a speed or can have a speed which is way faster than even a supercomputer. So, in case of supercomputers, whatever speeds we have just observed, whatever we just discussed, or the data that we discussed, quantum computers can very easily break all these records. A quantum computer can very easily do that. So, because the working of a quantum computer is pretty different as compared to any computer or any supercomputer, because these are computers that use the properties of quantum physics to store and perform computations. So here that's why even the memory unit is a different unit. For example, in case of normal computers, we use something called as a bit, correct? In terms of zeros and ones, we calculate anything with regards to bits, and these bits become the memory units. Here in this case, we have quantum bits or qubits. We have quantum bits or qubits. So these qubits or these quantum computers that use qubits, they are based on two principles that we just discussed. One is the principle of superposition, and the other one is the principle of entanglement. So these are the two principles on which any quantum computer is based upon. And because of these two concepts, what happens is that the kind of computation speeds that we would have with quantum computers are unimaginable. They can completely break any record that you have right now with any supercomputer. So that is why we look at quantum computer in a very different lens, where we see that it can completely change the world. It can completely change the way we do anything today. And for any application, for anything that we work upon, everything will have to be rethought or reimagined when we start using quantum computers in all these areas. But using quantum computers is not that easy, because the qubits that we are talking about, these qubits are very highly sensitive. All right, they are very sensitive, and that's why even a small departure from the ideal conditions can lead to these quantum bits losing their properties and not working properly. All right. So, for example, let's say even if a small change in temperature happens, there's a dust particle that enters that environment. Anything that can happen, anything external, it can lead to these quantum bits losing their properties, and this is called as quantum decoherence. This is called as quantum decoherence. Right. So now in this particular scenario, what we see is that quantum bits can very easily just lose their properties. So because of that, we do even use extra quantum bits. That if let's say 5 quantum bits are required, 5 qubits are required in any computation, we use 7, because we know that even a small change in their properties, a small change in their environment can lead to these quantum bits losing their properties. So that's why heat or electromagnetic fields and collision with air molecules, etc., they can cause a qubit to lose its quantum properties. So that's why we see that we need to protect these qubits from any kind of external interference. So that is why we'll see that additional qubits will be kept to ensure that these qubits do not lose their properties. So overall, when it comes to the working of these quantum bits, what we basically see is how the computation, just to give you a basic example of how computation becomes different. So let's say we have a normal computer. We have a normal computer versus a quantum computer. We have a normal computer versus a quantum computer. So now what happens in this particular case is, suppose that we are talking about a normal computer, then the memory unit that we have here is in terms of bits, right? And in this case, the memory units that we have, these are called as qubits. Right? These are called as qubits. So these bits are also in terms of zeros and ones, and even these qubits are in terms of zeros and ones. Now what we see is that, let's say, suppose that we are using a 3-bit system. All right. So if we have a 3-bit system, then it will lead to 2 to the power of 3, that is 8 states in total. Same happens here also, that if you have a 3-qubit system, then in that case here also you'll have 2 to the power of 3, that is 8 states. So all this might look very similar, but this is where the things will change. So for example, when I say that there are 8 states out of 3 bits, understand the meaning. How exactly 8 states? Like this: 000, 001, 010, 100, then 101, then 110, 011, and then 111. Like this, 8 states. So similarly, if you have 4 bits, there will be 16 such states will be produced. So just all the combinations of these 3 bits that can be produced is the basic number of states. So same happens here as well, that you'll have 000, then 001, then 010, 100, 101, 110, 011, and then finally 111. So you have the same states that you have here as well, but the difference comes when the computation happens. The computation that happens in case of a normal computer is serially, sequentially, one after the other. So for example, first this state will be computed, then it goes to this state, then it goes to this state, then it goes to this state. So one by one, all these states are being computed. So let's say if it takes 1 second for each of the state being computed, what we will see is that a total of 8 seconds will be taken. Okay, a total of 8 seconds will be taken for this computation to happen, because this computation is happening. Computation is done sequentially. Right? Computation is done sequentially, that is one after the other. Whereas in case of a quantum computer, what we see is that all these states are computed together. So computation is done parallelly. Computation done parallelly, meaning that all these states in total they would just take 1 second. So now what happens? You keep on increasing the number of bits. When it becomes 4 bits, it might take 16 seconds. This still takes 1 second. It becomes, you take 5 bits, it becomes 32 seconds. It takes 1 second. So in this manner, you keep on increasing the number of bits that you have in a normal computer, and the total time of computation will keep on increasing. Whereas in case of quantum computer, it will never increase. It will always remain the same. So that's why it takes a very less amount of time. Only after a very large number of bits, you will for the first time, you will say that from 1 second, it starts to take 2 seconds. Otherwise, it will keep on taking just 1 second. Why? Because superposition and entanglement, they are working. That all the properties of all these bits are they are related to one another, and they all can exist in multiple states at the same time. So that's why computation for multiple bits can be done at the same time. So that is why we see that quantum computers will completely take over whatever speeds we have for any normal computer. So applications, again, everywhere, wherever you need all the very fast processing, whatever application areas we saw for supercomputers, all those areas we can make the use of quantum computers as well. In all those areas we can make the use of quantum computers, and that's why we see that they can even fasten the entire processes that we have right now. Lastly, there is one more concept that we have related to quantum computers, and this is called as quantum supremacy. Quantum supremacy. Now, quantum supremacy is where a quantum computer is able to do a job, such a job within seconds, that a normal computer could not have done in its lifetime. So something that a normal computer could not have done in its lifetime, if a quantum computer can do that within seconds, then in that case it is called as quantum supremacy. So quantum supremacy is when a quantum computer can do such a job within seconds that a normal computer can't complete in its entire lifespan. So this is what is called as quantum supremacy. Now, why this image? Because few years back, Google had claimed that now we have reached quantum supremacy, and we have been able to do such a job with our quantum computer within seconds that a normal computer could have taken 10,000 years to complete. So something that a computer would have taken 10,000 years to complete, our quantum computer can do that within a couple of seconds. So that is what Google said. But then IBM came forward, and IBM said, look, what you are saying that 10,000 years could be taken by a normal computer, we have supercomputers that can do that job in 2 or 3 minutes. So yes, there is a difference, but there's not a stark difference that you can call it as quantum supremacy. So that's why Google claimed that it is quantum supremacy. IBM said that no, this is not quantum supremacy. The following year, IBM came forward and they said that now we have reached quantum supremacy. And then Google came forward, they said no, it's not quantum supremacy. They also found a technical problem there, and they said that no, what you have achieved also is not quantum supremacy. So quantum supremacy, or also called as quantum advantage, quantum supremacy, or also called as quantum advantage sometimes, because supremacy is also a term that has a racial connotation to it. Racial supremacy is the context, and that's why many do not prefer the word supremacy instead of the word advantage. So in India, we have seen that first time in the budget of 2020, a total of 8,000 crores were announced for the next 5 years, so that in quantum technologies, India can start working in various different fields. So in various different fields, how exactly we can make the use, we already have started working on that. And then we see that there is this quantum frontier mission that was taken by the government of India, and this basically is to start developing various different quantum technologies, whether it is quantum computers or quantum chemistry, quantum communication, anything that can use quantum technologies. India is going to start working on it, and that is why this quantum frontier mission was taken. And as a part of this mission, we see that there is a research and development scheme that we have called as Quantum Enabled Science and Technology, or QUEST. This is something that we have now to realize the developments that can happen in various different fields of application of quantum mechanics, whether it is quantum computers or quantum cryptography or quantum engineering or quantum chemistry or whatever it is. In all these things, whatever research and development can happen. So there are various themes that have been taken as a part of this QUEST mission. Now, what exactly it is, we don't need to go into the details of it because it's too technical for anything to be asked in the examination. But just remember that there are 4 themes under which this scheme is being taken, and there are all these things that are being analyzed as a part of these 4 themes. So that is basically what they have done, and that's why they have all these objectives that they have taken as a part of the development of quantum technologies in various different fields in India. So just know the facts about all these things that we are discussing. This was asked in your 2022 paper. Very simple question. Please mark your answers. I'm hoping that I get 100% correct answers here. Still I have 95% correct answers and not 100% correct answers. Anyway, so we just discussed qubit is what? Qubit is quantum bit. Quantum bit is used where? Quantum bit is used in computing. So that's because it's the first time that they have asked a question. So that's why a very simple question has been asked. Next time they ask a question, the question will not be that simple. Question can step up in its complexity. Anyway, so let's take a break here. The time is 7:50. Let's be back by 8:05, and then we shall start our last chapter, that is intellectual property rights. And meanwhile, if you have any questions, whatever we have discussed, please post your questions. I'll take all your questions and then we shall proceed further. Frontier is owned by US. It belongs to the US. What are the main characters of quantum computing? So quantum computing, basically, character-wise, you can say that the processing speed is the most important character, because it would be able to uh, do the computations at a speed that is unimaginable. The characters mainly are also about how the systems work and how the systems function, because it's a very different kind of computer. It's not your basic computer that you think of. It's a very different machine altogether, which will be kept in a very isolated room at very low temperature, temperatures almost being at almost minus 270 degrees Celsius, so that it is completely freed from all the external things that can lead to any kind of disturbance in the system. What is IBM full form? IBM full form is International Business Machine, one of the most important, one of the biggest companies in the software sector in the world. I want to ask a question from quantum mechanics. How do quantum particles behave different from classical particles? Quantum theory's impact. How has quantum physics influenced our understanding of the universe and technology? So first and foremost, how do quantum particles behave different from classical particles? It's basically about the properties that they showcase. So for example, the particles in the classical field, they would basically be run by gravitation. Gravitation being one of the most important properties that would run at the macro level. Whereas in case of the properties of quantum particles basically will be run by the subatomic level with the help of quantum physics. And that is the basic difference that you have between these two particles, or these kind of particles. So that's why their physics, their behavior, their properties, they are completely different. Classical is everything that we feel, what we do, how thermodynamics works at our level, how magnetism works at our level, how gravitation or classical mechanics works at our level. So that's very different. And the second question that you have, how has quantum physics influenced our understanding of the universe and technology? So there are a lot of things where we see that the things have been understood very differently. For example, when we discuss about dark energy and dark matter, one of the reasons why we even could think about dark energy and dark matter in terms of the understanding of the universe was because our understanding of the various different forces also started to develop. At the same time, the entire digital world, entire understanding of today's internet and everything, it starts to stem from the quantum mechanics, how the discrete energy levels work, and how there is a difference between the discrete energy levels, and not all the energy levels are continuous. This is where the things had started from, and that led to our basic understanding of things at a subatomic level. Because until then we had no proper understanding of the subatomic level, and that is where we then see that the modern atomic theory also stems from. The entire everything that you do in the digital space today, it's all the understanding of the packets of data and the quantum of data. It all basically comes from our basic understanding of quantum technologies. Quantum mechanics is the reason behind not taking physics as my optional, despite having masters in physics. I totally understand you. I know how difficult the things can be at quantum level. There was a time when I was also thinking of physics as my optional subject and did not take physics because of one of the strong reasons being quantum. Is this the last class for science and technology? Yes, I mean, topic-wise, this will be the last class. Although tomorrow also we will have a class where we'll discuss about all the doubts that you have. Plus, I'll discuss some of the key questions from the past year paper. I mean, this year's prelims paper. Will the facial recognition done by Google Photos be counted as cloud computing? No, facial recognition is artificial intelligence. It's the use of image processing using artificial intelligence. But yes, the data being stored in Google Photos, for example, that you can call as cloud computing. Are quantum computers supposed to be faster than supercomputers? Yes, yes, yes. I mean, completely way faster than supercomputers. They can be very, very fast. On what basis will the nodes know if the transaction is a fraudulent one or not? It's a very difficult thing for any node to even understand whether it's a fraudulent transaction. It depends on the volume of money being involved and the kind of transaction that is happening. The nature, the repetitive nature sometimes can also be one of the key factors. The parties between whom the usernames or user IDs between whom the transactions are happening. So all these can be various factors on which somebody might want to comprehend whether it's a fraud transaction. But otherwise, it's a very, very difficult task for anyone to know. El Salvador made a blockchain tech a legal tender. Yeah, in certain cases it has been done. I mean, even in the US, for example, in certain cases it is allowed, but not allowed everywhere. In India, it is a complete ban. What are the disadvantages of quantum? So if you are talking about the disadvantages of quantum computing, then in that case, first and foremost, again, it can pose a big security threat for everyone. Any kind of cryptography that we have today, any kind of encryption that we run today, each and every one of these encryptions can be broken with the help of quantum computers within seconds. It will not even take a lot of effort for it to break. All the probabilistic calculations that take a lot of effort and time, they all can be done within seconds with the help of quantum computers. So that's why they will lead to all these issues. Plus, the kinds of automations that it can lead to is also unthinkable, and it will be again a participant in a lot of people losing their jobs in these kind of sectors, because it will make a lot of technology of the day completely irrelevant. So from that perspective, we'll see that a lot of people who are involved in all these technologies, they would start losing out their jobs. And for the countries, for cybersecurity, for everything, it can pose a lot of threat. And that is also the reason, one of the reasons why everybody is just racing towards achieving quantum technology, whether it is India or China or US or the majority of the European economies. We see that everybody is running behind implementing quantum technologies and quantum computing as quickly as possible, because the one who's late in this race might face a lot of issues. So that's why, especially for the bigger economies that have a lot at stake and where they have a lot of competition from others, they have to try and win this war and win this race as quickly as possible. So that is why here one of the threats for India also is seen as how China has been advancing, because nobody has invested as much money in quantum computing as China. That even compared to how much money US has spent on quantum computing, almost 15 times that money has been spent by China on quantum computing. And now we being one of the contenders with China, competitors with China, we have to understand the severity of the situation, and that's why we are also trying to spend or invest a lot of money in quantum computing and win that race. When there is a reward attached to the correct validation, why would somebody invalidate the transaction? Because see, if you are doing wrong validations and it has been caught by others that somebody is doing a wrong validation, you could be reported for doing that and you could be blocked from the blockchain. So that's why they try to maintain as much transparency as possible. What is International Space Station? Let's discuss this tomorrow. All the doubts that are related to the entire topics. Let's discuss this tomorrow. Quantum topic is important for exam or not? What is this question? Why would I teach this in the classroom if it's not an important topic? Can we say that all nodes are users, but all users are not nodes? Yes, you can say that. Tomorrow class will also wind up 9:30. Depends on how many doubts we are looking at. If the number of doubts are lesser, then maybe before the finish time also we'll be able to finish off. It just depends on, how many doubts you all have for the class. So as you said, there would be a complex problem that must be solved to validate the transaction, and all the nodes have to validate it for it to become a block. Then what if a node cannot solve that problem? See, it's about the time that it takes. If the node is not able to, then it's fine. It's about whether you validate or you don't validate. So if they are validating, then they are participating. If they are not validating, it's fine. They have not been able to validate, it's okay. But they should not invalidate. That's the point. If they invalidate, then it's a problem. If they validate, it's fine. If they're not able to, that's also fine. But invalidation should not happen. Difference between quantum and supercomputers, completely different technologies. I mean, one supercomputer we discussed that they are based on bits, just that their computation speeds are very fast. Whereas quantum computers are based on quantum technologies, completely different technologies altogether. Is quantum computing used in or by any organization? Some of the biggest companies, they already have quantum computers. For example, IBM has one, Google has one, Meta has been working on it. So we know that all these big tech companies, they already have a version of supercomputers, sorry, their quantum computers. China also has it, US also has it. So these all also have quantum computers. Yet they haven't found a way in which they'll be implementing it in various different application areas. M2M communication means M2M means machine to machine. So where there are peer-to-peer communication happening between machines. When each user is given an address and it can become an identifier of such a user, how can blockchain then be completely anonymous? Because it's just a username, You cannot find any detail about the user from that username. So let's say I use a username that is, let's say, 12345. Now you don't know who this 12345 is, what the name of this person is, where does the person belong from, what is the email ID, what is the identifier, what is the let's say even the IP address of the computer that I'm using. You don't know anything. You just know that there is somebody called as 12345. That's it. So that's why it is not traceable from that username. I watched a Black Mirror episode of quantum computing. It was dangerous. Yes, Black Mirror. I mean, the thing about Black Mirror is this: that everything that they have shown has been a kind of a prediction. And even if you go on Google and if you type Black Mirror predictions, you'll see how many of the science fiction episodes that Black Mirror had aired. Those things that were science fiction in 2011 and 2013, they have become a reality today. So yes, that goes for every episode that they have. Supremacy is when when anyone says that we have a quantum computer that can work at a speed which is unimaginable speed, which can go way beyond any kind of computation speed that you have today. Boson. Boson, let's discuss tomorrow because it's completely unrelated to today's topic. Applications of quantum and supercomputers are the same. You can say that both are being used for the same thing. Just that quantum computers will be able to do that work even faster than the supercomputers. Is it true that if you forget the user ID and password of a cryptocurrency, we are not able to retrieve? No, as long as your account exists and in one way or the other you can retrieve your information, it's doable. PPTs are enough for revision. They should be PPTs. The unread PPTs should be enough along with your current affairs. What are these clouds in exactly? Clouds basically are, let's say, servers. They are nothing but servers where you have storage data. So for example, let's say how your computer might have 500 GB of storage space. Similarly, there is a storage space that would have, let's say, a huge amount of storage capacity, and that is basically being called as cloud. I don't receive any email from ISBHLP. What can I do? Please write to support for this, maybe to targetis@byju's.com or islive@byju's.com. They would help you solve that problem. Qubits, how do they differ from bits? They differ in their properties. The basic properties are different. That qubits are working on quantum properties, whereas bits are working on the basic properties of memory storage. Is there any type of computer that is faster than quantum computer? No, not right now. Can you please tell of any app where I can practice English, where I can talk to the app free without payment? I'm not sure. I'll have to see whether there's something which can help. Right, so let's move ahead. The last chapter that we have is intellectual property rights. Now, with regards to intellectual property rights, from the examination perspective, I would say that it's a chapter which is more important for your mains examination than your prelims. And also, when it comes to this particular chapter, this is more of a discussion-oriented chapter and very different from all the technology-based chapters that we have discussed until now. So, compared to them, you'll find that this chapter is very, very different. Now, first and foremost, when we say intellectual property rights, what do we mean by intellectual property, and what are these rights that are associated with this intellectual property? So, let's try to understand that. So, first and foremost, when it comes to intellectual property, intellectual is what? The meaning of intellectual is something that is related to the brain, something which is related to application of the brain. So if there is something that has been created by the brain, we could say that it's an intellectual property, creation of the brain, any kind of creation. It could be a new invention altogether, or maybe it could be a new story that you've written. It could be a new film that you perhaps have made, maybe a piece of music or a lyrics that you've written. So all these things, they can be called as intellectual property because they are creations of the brain. So that's why any right that is associated with the creation of the brain will be called as intellectual property rights. So that's why intellectual property refers to creation of the mind, such as inventions, literary and artistic works, designs and symbols, names and images used in commerce. So that's why all these things, they can be called as intellectual property. So now all the rights that are associated with intellectual property, they can be called as intellectual property rights. Now overall, when it comes to intellectual property rights, first thing that we need to understand is what exactly do we mean by these intellectual property rights and why do we need it? So let's say, for example, in your mains examination, there is a question that why do we need to protect the intellectual property, or what is the need for intellectual property rights? So for such a question, understand the meaning from two perspectives. First, from the creator's perspective, but at the same time also from the consumer's perspective. Because creator's perspective is something that we understand by its design, that if somebody is doing something, somebody is making something, protect their rights. They should be able to use them because they are the ones who have put all the effort and money behind making that possible. So obviously they should be protected. So that's why from the creator's perspective, we understand that it increases their capacity to create and invent. The protection can also encourage further innovation, better research and development can happen. And if not anything, at least it is the acknowledgement of the work for whatever they have done. So obviously for any new innovation, any new invention, a new product or a new process, somebody would have spent a lot of time. Somebody would have spent a lot of time and they would have made a lot of effort in making something like this possible. Correct? So that's why because they have put in all the effort, they have put in all the work, they have to be protected. Otherwise, somebody else can just use it, and whatever time, money, and effort was spent by this person or this organization was for nothing, and they have no gains out of it. So that might also discourage them from anything, doing anything further. Correct? They might not want to do anything further because they see that there's no benefit for them. Forget about they earning anything out of it or they getting a good name out of it. Nobody even knows that they had made it. Somebody else is getting all the benefit out of it. So that's why the creators' rights have to be protected, so that they, under this mechanism, they can be helped, and that encouragement will also help them go further. But at the same time, creators' perspective is fine. But even from the consumer's perspective, we understand it's a very, very important thing. That, for example, it can lead to an economic growth. Why am I saying this? That why does it or how does it lead to an economic growth? Consider mobile phone. Where did it start from? It was just a device that would help you talk while you are somewhere outside. When you are not sitting in front of your phone, beside your phone, you can still be connected to anyone you want with the help of this mobile phone. That is where it started from. And look at where it is right now. That today, if you go to buy a phone, you do not even ask that whether it will help me talk properly or not, or is the voice clarity good enough. I don't think that these are questions that we ask when we go to buy the mobile phone. We'll ask about the camera, we'll ask about the processing speed, we'll ask about the screen, we'll ask about all these advanced features today, and we'll not ask about whether it will help us talk or not. So voice quality is not even a concern today. But it's not only about the growth of this mobile phone, but also everything around it. It's not only that the mobile phone companies have grown and they are the ones who have gained, and the service providers have gained. But today, look at not if not anything, we know that every company now has a mobile phone app. Every company more or less has a mobile phone app, and they basically get a help. They can get a visibility through these apps. Forget about even those companies and everything. Just look at how many self-employment opportunities it has created. Just go around your town and you'll see that there are so many small mobile phone repair shops which are repairing mobile phones or selling accessories for mobile phones and doing all these things. So a lot of people are also being able to self-employ just because of the growth that mobile phone has seen. So that's why today we see that there's an entire economy that runs on a mobile phone. Correct. So that's why a kind of economic growth that it has led to. Similarly, better and more efficient products. Today, if let's say somebody manufactures a mobile phone that is not going to last for a year, suppose, then I don't think that then anybody is just going to repeat that purchase. And not only that, they would also discourage others from purchasing. They would have a bad review on the internet, and the company will just go. If they cannot make a good mobile phone, they cannot make a reliable mobile phone. And that's why we see that anyone who has not been able to live up to the expectations of the public or of the consumer, they just have vanished. Just look at certain examples. BlackBerry. I don't know whether how many of you know about BlackBerry. Used to be one of the premium mobile phones a decade back, and today nowhere to be seen. BlackBerry is gone. Why? Because the kinds of technologies that they were using, the operating system that they were using, that could not grow with the kind of growth that Android and iOS saw. So that's why Android and iOS, because they got a thumbs up from the public, they kept on growing. Whereas the others, they failed to grow. Same happened to the biggest mobile phone company of a time, Nokia. That Nokia first 10 years they were the rulers of the world when it came to the mobile phones. But then after that, they chose Windows as their operating system. Whereas some of the other companies, they chose Android. For example, a company like Samsung or Sony, they chose Android, and then Apple runs on iOS. So these two operating systems were completely accepted and very much liked by the people all around the world, whereas Windows was not. And we see that Nokia vanished. Reliability of the product. A company which started to grow very quickly and also lost its market very quickly. Micromax, an Indian company, an Indian mobile phone manufacturer, started working on very cheap phones, on phones which would be very affordable for everybody. But at the same time, the quality was not up to the mark. And that's why when the Chinese companies started to flood the Indian markets, which were of the same price category, giving you a lot more features and being reliable, lasting longer, giving better batteries. Because of all these basics, we saw that all those Chinese companies, they just took over the Indian markets. And an Indian company that was doing well, two of the Indian companies rather, one being Micromax and another being Lava, we saw that these companies just vanished because they could not live up to the expectations of the consumer. So that's why we have seen that all these things happen, and that's why with the consumer demands, with the consumer needs, the companies and the sectors also need to grow. Same goes for even publications, music, or film. That we see that in these kind of cases also, it's the consumer that runs the show. So, for example, in case of films, if we see that the film is not being liked by the consumer, let's say a certain kind of film is not being accepted by the consumer anymore, those kind of films will just die. You'll see that all of a sudden they will not be accepted by the people, and they'll not be made anymore. We saw that, for example, in the couple of years of after COVID, that all of a sudden when online so many films were available, there were OTT platforms which came in, and a lot of international stuff was also available in India, also dubbed in all the local languages, whether it is Hindi or Malayalam or Tamil or Kannada, Telugu. We see that in all these languages also, all these international films were also translated. They were also dubbed, and that's why for a person that does not even understand English, for that person also it was very easily available. And now all of us also got accustomed to a lot of good content that until now was not available. A lot of small filmmakers in India also got their voices through these OTT platforms. Otherwise, for them to release a film in the theater would have been impossible with the kind of money that they had. So now we saw that better films, better stories, etc., were now available to everyone, which also you can say made the bigger filmmakers also think and re-strategize and also look towards the films that the people would like instead of just making starry and massive films. So we see that all these changes happen. Not only that, even in the publications we see this, that the kinds of books that you see in the market. So for example, if you go to a big bookshop, whatever you have in your space, you'll see that today there are a lot of books which talk about personal finance. They talk about money. They talk about how you can save your money and invest your money. Why? Because today we see that India has a lot of young population who's earning, and that's why they have that money that they want to spend. They want to invest somewhere so that they can secure their future. This number was not very high 10-15 years back. 10 years back, if you go to a bookshop, you might find a lot of self-help books, a lot of books by Robin Sharma, a lot of books by Paulo Coelho, etc. Books by Shiv Khera, like You Can Win, etc. All these books, they basically had a lot of market because that was being accepted by the public in general. And then we also saw books like where Indian fiction started to come in, with Chetan Bhagat becoming very popular. We saw that a lot of other Indian fiction was also written. These books were special because these had very easy language, and a language that anyone in India would understand. Otherwise, the English fiction that we were used to had a kind of complex language and not everybody's cup of tea. So that's why we see that because consumer demanded, these kind of books also started to flood the markets. So that's why we see that in every case, the consumer also drives these kind of markets, and IPRs are largely driven by the consumers as well. So that's why it does not only help the creator, but it also helps the consumer. In both the cases, we have seen that in all these areas, IPRs have actually helped. Now, when it comes to IPRs, we see that there are multiple different types of IPRs that we have. There are 6 basic types of IPRs: patents, trademarks, copyrights, trade secrets, industrial design rights, and geographical indication. So we'll discuss about all these types of IPRs one by one, trying to understand what these IPRs are and how they function. So first one here is a patent. Now, in case of a patent, what we see is that it refers to a set of rights granted by a sovereign state exclusively to an inventor for a limited period of time in exchange for detailed public disclosure of an invention. And it is used for protection of new inventions, ideas, or processes. So understand what's happening here. Suppose that I made something new. Suppose that I invented something. Let's say I am the inventor of a fountain pen. So I'm the first one who has invented the fountain pen. And then with that fountain pen, I go to the government and say that, look, this is a new product that I have made. I want an intellectual property right associated with it. I need a patent for it. So to get that patent, first I will disclose all the information about this pen. How exactly did I make this pen? What was the research that went behind the scenes? What are the things that I'm using? What is the process that I'm using? What are the ingredients, for example, that I'm using? So each and every minutest of the information will have to be disclosed to the government first. Right? I'll disclose all this information to the government of India first. And once I've done this, once I've disclosed this information, then only I would, then after that, the government will start analyzing whether there is something similar that already exists. If somebody else has already filed for a similar patent. So if there is nothing like that, if let's say there is no significant overlap with anything else that already exists, then in that case, the government will say that fine, you have the patent. So then I will be granted by the patent by the government. Now, once I have been granted the patent, there will be a definite fee that will be paid periodically to the government. Will be a small fee that will be paid to the government. And at the same time, once I have been given this patent, now I have the exclusive rights to use this invention, a new product, whether it's a new product or even if it's a new process. I have the exclusive rights. I can do whatever I want with it. If I want to sell it in the market, I can do that. If I want to sell it on my own, I can do that. I want to give the license of this product to another company, I can do that. I don't want to do anything. I just want to keep it with myself, keep it in my locker. I can do that. So I have the exclusive rights to do whatever I want with this invention now that the government has given me. So this is what we see with patent. Now, one thing that also matters here is that we say that patents are territorial rights. Right? Patents are said to be territorial rights. Why? Because whichever government has given me the patent is applicable only in that country or that region. So, for example, let's say if the government of India has given me the patent for this pen, then this patent is applicable only in India. I cannot go to Pakistan and say that this patent should be applicable here as well. If I want a patent in Pakistan, I'll have to go to Pakistan and talk to whatever government exists there, whether it is the democratic government or the army, whatever is running the show. So I'll have to ask them first, and then they will give me the patent, and then only that patent will be applicable in Pakistan. All right. So that's why patent is applicable only in the country which has given me the patent, or the region. In case of Europe, it's the European Union. So once it is applicable, it will be applicable in the entire European Union. So in this manner, patent. That's why we say that patents are territorial rights. Then after that, we see that it is granted for a limited period, generally 20 years of time. So if the patent has been given today, it will be applicable for the next 20 odd years. So for the next 20 years, I have it. If I want, I can renew the patent after that. If I think that there is something, nobody else still has this technology and I'm still the market leader in this technology, I would want to implement that further. I would want to take it further. And that is how basically we can use patent. This is also sometimes misused by many companies. And this is where something called as patent evergreening works. Patent evergreening. Now, in case of patent evergreening, what happens is that a company sometimes might want that I just want to continue with this patent. So for that, they might do a small change in their product, and they would say that, look, now that the change has been made, this is a new product. This is a new product. It should not be considered as the same product. So now I should have a new patent on it. It's not a renewal of the patent, but rather a new patent because there are changes that I have made. So, and especially in the pharmaceutical industry, we see that it happens a lot. That in the ingredients that the companies have, they would make a very minor, insignificant change, and they would come to the government with that insignificant change and say that, look, this is a change, and hence it should be a new patent for me. And in this manner, they'll keep on extending that patent for as long as possible. So that's something. Something like this is called as patent evergreening. Now, what we see is that in India, there are rules that ensure that patent evergreening cannot be done very easily. Otherwise, we see that in a lot of ways, a lot of companies, especially in the pharmaceutical company sector, they keep on using the strategy for patent evergreening so that they can extend the patent for as long as they can. So that is basically what we see here, and it can be very dangerous for this entire segment, because especially given the fact that it is a pharma sector where medicines and people's lives are involved. So this basically you can say that this is continuing extension of patent rights by making small changes in the existing product. Right? So whatever they have right now, they would just make a small change there, and then this small change will lead to a new patent evergreening. So that's why we see that this is a practice. We'll discuss about that later. Then after that, we have copyrights. Now, in case of copyrights, copyright is given to the creators of literary, dramatic, musical, and artistic works, and producers of cinematograph, films, and sound recordings. Now, in this particular scenario, when it comes to copyrights are given for expression of ideas. In patents, we are saying that these are given for having new ideas or new products or processes. Here, we are saying that it is given for expression of those ideas. So that's why it will include everything like this. The literary works such as novels, poems, plays, reference works, and newspaper articles. Computer programs and databases will also be included. Films, musical composition and choreography, artistic works such as paintings, drawings, photographs and sculpture, architecture, and even advertisements, maps, and technical drawings. In all these cases, copyrights will be given. So that's why just remember that copyrights are given for expression of ideas. So for example, you cannot just get a copyright for having an idea about writing a book. You cannot go to the government and say that, look, I have thought of writing a new book, so please give me a copyright to it. No, unless your manuscript is completed. When your manuscript with that book is completed, only then you get the rights, the copyright for that. So that's why it extends only to expressions and not to ideas, procedures, methods of operations, or mathematical concepts as such. So that's why anything that is natural cannot be copyrighted. So any physics law cannot be copyrighted. Any mathematical formula cannot be copyrighted. You cannot say that, look, until now nobody has a copyright over 2 plus 2 equal to 4. So that's why from tomorrow, now I'll go and apply for 2 plus 2 equal to 4, and hence I'll have the copyright for 2 plus 2 equal to 4. So from tomorrow, if I have to write 2 plus 2 equal to 4, then I'll have to take permission from that person. So So that's why all these things will be called as copyrights, right? All these things will be considered under copyrights. So that is what we see here. Even for example, I mean, this PPT that I am using here, you can say that this also is covered under copyrights. So here also the copyright belongs to the company. Unfortunately, it does not belong to me, belongs to the company. So this is how we see that copyrights work. So there are two types of rights that are covered under the copyrights. One is the economic right, and second called as the moral rights. Economic rights, basically anything which, in terms of any financial reward or any financial benefit that I get out of these copyrights, that will be counted as economic rights. And moral rights are more about the acknowledgement of the work. That even if, let's say, I'm not getting the money out of it, I'm not I'm not just being paid for it, yet the acknowledgement of the work lies with me. So that acknowledgement of the work is also very, very important thing, especially for the authors. Especially for the authors, it's a very, very important thing that they have a moral right, they have an acknowledgement of the work, even after they don't have any financial benefit out of it, even after, let's say, it has been a long time since they have written the book, but yet the acknowledgement of the work is still with the author, and that's why that also becomes a crucial part of covering copyrights. Then after this, we have trademarks. Now, in case of trademarks, what we say is that this is a sign that is capable of distinguishing the goods or services of one enterprise from those of other enterprises. Now, in this particular scenario, what we see with trademarks is that it can be a sign or a symbol. It can be anything. It's not only about, let's say, something like a logo. Something like a logo that distinguishes the products and services of one enterprise from those of the others. For example, this logo belongs to Byju's. So wherever you see this logo, you will know that this is a product or a service that belongs to Byju's. But it's not only about the logo being used or a sign being used. For example, a quarter eaten apple. You always know that it belongs to a company called as Apple. But there are other things also. So for example, let's say even the shape of the Coca-Cola bottle. That also is covered under trademark. That how exactly the shape of the bottle is, the way in which the picture is made, even the font that is used in writing the name of a company. You'll see that even the font does not change. So that font even is considered as a trademark. So that's why it can be anything. It can be a sign, it can be a symbol, it could be a way in which you're writing the name, it could be even the shape of the bottle that is being used by the company. Each and everything will be considered under trademarks. So that's why whether it's a shape or size or color or name or signs and symbols and whatever it is used, in all these cases, we can say that these are all trademarks. These will all be considered under trademarks. So after this, we have industrial design rights. Now, in case of industrial design rights, these are more about the visual design of the objects and the other aesthetic parameters, which are not purely utilitarian. That is, they have no bearings on the function of the object. They do not have any bearing on the functionality of the object. So, a simple example. Batman mask. There's only one job that the Batman mask has to do, and that job is to conceal the identity of Batman. That nobody should know who the Batman is, right? Nobody should know who the Batman is. Just that you would just know that the face is hidden by the mask. But if you see over the years, there are different types of masks, different designs of masks that have been used. So that is what is called as industrial design, right? Where we are not talking about how exactly the functionality is different. Functionality will remain the same, just that the designs are different, the shapes are different. Same goes for example, let's say a car, a new car that is released in the market, or let's say even a new mobile phone that is released in the market. The very first thing that will happen is that the first look of the mobile phone or the first look of the car, etc., will be released first by the company, and then after that, later about the functionalities and everything they talk. So, because we know that even this design of this product also has a lot of impact on the market. That if, let's say, the car design is being not liked by the people, by the consumers, it may not sell well in the market. Even it might be one of the best cars that have ever been manufactured in the segment, yet it will not have that reception from the public if it does not look good. So that's why industrial design right also becomes very, very crucial in the commerce of any given product. So that's why we have to understand that this is how the things are when it comes to industrial design rights. Then after that, we have trade secrets. Now, when it comes to trade secrets, these are things which are protecting the secret of a company. Right? They are just trying to protect the secret of a company. Now, when do we need to protect? When this is an information which is very easily copyable. That's something that I can copy very easily. Those kind of things, and I cannot stop anyone else from copying it, or I cannot even claim that somebody has copied it. So then, in that case, we'll see that trade secrets work. So that's why it should be commercially valuable, and it would be known by only a limited group of people, and also it will be subject to reasonable steps to be taken by the rightful owner of that product. So there are various examples. Coca-Cola, Maggi Masala. So, for example, let's say you have Coca-Cola, you have Thumbs Up, you have Pepsi. All these have the same color, almost the same color, but the tastes vary. There are significant differences in their taste. So that particular taste is something that you cannot stop some from third party also from replicating. So that's why you have to keep it a trade secret so that nobody knows how exactly you're making it. Same goes for the Maggi Masala. Maggi does not sell so much because of the noodles. It sells because of its spices, the masala that they are giving along with Maggi. That is something that sells. That is the selling point for them. If somebody is able to replicate it, if they are able to produce the exact same taste, let's say for a lower price, then in that case, Maggi will simply lose its market. Right? Maggi will lose its market because now there is somebody who has been able to replicate it. So that's why this will be kept as a secret, so that it does not become a common knowledge, and should not be that everybody is able to just copy that information or just copy that product. So that's why all these basically they become a part of the trade secret. In the companies, many of the product-based companies also, they will ask their employees to sign a confidentiality agreement, or non-disclosure agreements will be signed. So these non-disclosure agreements or confidentiality agreements are also signed, so that this information is not passed on by this employee when they go outside. So they should be keeping that a secret, because now they're legally bound to keep it as a secret. So that also will happen in a lot of tech-based and product-based companies as well. Then lastly, we have geographical indication. Now, in case of geographical indication, we see that this is a sign that is used on a product that have a specific geographical origin and possess qualities or reputation that are due to that origin. So, because of the origin, because of where they are coming from, they have a value in the market. The most common example is the Nagpuri orange. The Nagpuri orange is known for, if let's say the orange is coming from Nagpur, it has a standard quality that it would have compared to any other orange that we have in India. So, and again, there are a lot of products. There are more than 50, 60 products that have been given this kind of geographical indication. Now, what we see is that it may not always be a food product or an agricultural product. It could be handloom. It could be, let's say, a kind of silk like the Mysore silk, or let's say a sari like the Banarasi saris. So in all these cases also we see that these kind of geographical indication would be given, so that the uniqueness of the product, because of the origin that they have, that can start to make a market for itself. That can become a selling point in the market. A very simple example. And also a controversy between Odisha and West Bengal, Rasgulla. Now, in case of Rasgulla, there has been a controversy that should Rasgulla or Rasgulla, as you call it in Bengal, should Rasgulla belong to Bengal, West Bengal, or should it belong to Odisha? So there is one problem here, or one controversy here that has happened because of the origin, because of the history. And when we go back in history, we trace back the history to two different forms of this Rasgulla. One where the origin is in Odisha, and there is one origin that is there in West Bengal. And this is a very controversial topic. I'm sure that there are people in this classroom who are from West Bengal, and there are people in this classroom who are from Odisha. So I don't want to take sides. So in this picture, basically what we see is that there are two pictures that you can see. There is this brownish colored Rasgulla that you have, and then you have this white one. So this brown one, which is also called as Pahala Rasgulla, this basically is something that belongs to Odisha. And then this white one that you have, this is something that belongs to the West Bengal. Now, this is how the government has tried to solve this problem. The Chhena Rasgulla belongs to West Bengal and the Pahala Rasgulla belongs to Odisha. Although tracing back history, it probably seems that Odisha had it before West Bengal, but I'm not going there. Although you know that these are connected areas, so they share a common border, so it's very difficult to trace back the exact history. But yes, as far as we know, and all the manuscripts that we have from the medieval times and the ancient times, it looks like it belongs to Odisha. So these are the two. I mean, this also has been a controversy. That of course, because of the geographical origin, you would want to have that if it belongs to that area. If, for example, let's say I come to visit you and I say that I have bought Rasgulla for you from Mumbai, you'll not be interested. But if I say I have vada pav for you from Mumbai, you'll be interested. Correct? So that geography, that origin, has a bearing on whether it will be received well or not. So that's why. But anyway, let's not keep this slide for very long. I've not eaten anything, and I don't get good Rasgullas where I am right now. So yeah, this is it. So overall, this is about this. Now coming to the next topic, and this is about the national policy on IPR. So we understand that we now have an IPR policy also, and this IPR policy was very much required for us because of the way we look at IPR policy, way we look at IPR, and in a manner you can say the kind of ignorance that we had towards IPRs, because our understanding of IPRs hasn't been that great, and we haven't understood the value of IPRs, the kind of value commercially or socially or culturally that it can create for us. So that's why we thought of having an IPR policy, and in 2016, a national policy on IPR was brought in by the government. But it's not that before that we haven't had any laws for IPR. We did have laws. We have the Cinematography Act, we have the Farmers' Rights Act, we have the Patents Act, we have the Copyrights Act. So there are all these acts that have existed forever, even since before India's independence. There are laws that were made by the British, and the same were taken over by India also with slight modifications. So that's why we see that in all these cases we did have IPR laws, but the problem was that all these IPR laws were acting independently. That there is one law only for patents, there is one set of laws only for copyrights, and so on. So we needed to have an umbrella policy that can cover each and every law, that can cover each and every aspect of intellectual property rights. And this is where we see that we move to having this national policy. So major objectives: the first one was to spread awareness on IPRs, that we should understand the social, economic, and cultural value of having IPRs and why they become important for us. And once we understand, once we are aware, it would lead to generation of more IPRs. That then in India also will start generating a lot more IPRs than we do in the current scenario. And we saw that a lot of IPRs were being lost. So, for example, we see that something like a basmati rice was given the patent, was patented in the US, in Europe. Similarly, we see that in US also it was. Then turmeric, the medicinal properties of turmeric, something that we just know by design because of the passed on information from generation to generation. But the medicinal properties of turmeric were patented in the US. Then yoga postures, even yoga postures were patented in the Europe. So just imagine, now you would feel that, okay, fine, patented in the Europe, how does it matter? Because Europe's patent have nothing to do with India. It would if somebody who's an Indian or an Indian company goes there. So, for example, let's say somebody who's a yoga instructor or a yoga guru tries to go, let's say, and have their seminars and their they want to teach yoga in Europe. They legally cannot, because there is somebody else who has a patent over yoga postures. So they can't really go there and practice that. So that's the issue. That let's say today an Indian company wants to sell a turmeric-based product in the US, they can't patent it there because somebody else has a patent. So they can't derive the economic benefits of it because somebody else already has. Although they were not the owners of it, but because we were ignorant, because we did not find the value in IPRs, we never generated these IPRs. So that's why it becomes very, very crucial from this perspective that India should have an IPR policy. Then also to provide legal and legislative framework and the administration and the management of the IPRs. In all these cases, we do see that it becomes very, very crucial in all these aspects. So that's why from the perspective of all these things, we have to understand the value of the IPR policy. That now there will be one framework that will help in IPRs. There will be one ministry, one department that will help. The legislative and the legal frameworks will also develop better, and they will also protect the Indian rights before anything else. So that also we see as major objectives. Then commercialization of IPRs can be done better. That they will start generating a value in the market, and hence they'll start to grow in the market as well. Then it will help in better enforcement and adjudication of IPRs. That IPR laws, basically any infringement of the law can also be handled better when we have this kind of policy. And development of human capital, because we need people to strengthen and expand the IPR regime in India, and that's why whether it is about the tech sector, whether it is about the startups, whether it is about the legal framework that we want to develop, in each and every one of these things, we see that this IPR policy would help. So that's why all these things, they become the basic objectives with which we look into the IPR policy. So then talking about the highlights of the policy, what exactly the IPR policy says, first and foremost, the tagline that has been given to it is Creative India, Innovative India. The tagline for the policy is Creative India, Innovative India. And then as a part of this, now what we see is that it includes all the rights, it includes all the acts, whether it is the Patents Act, Cinematography Act, or whether it is the Copyrights Act, or whatever act it is. We see that all these things now will be covered under the regime of the IPR policy. So that's why it provides various intellectual property laws in order to remove any anomalies and inconsistencies that we have here. At the same time, any kind of financial aid that is required for the IP owners and will also be provided, whether it is through some kind of funding, whether it is through direct or indirect tax benefits, whether it is through venture capitalists, whether it is through angel funds. We see that in all these cases, even banks will be able to provide certain IP-friendly loans. So especially when it comes to the relatively less empowered groups of IP owners, we'll see that the banks will become very, very crucial. The rural banks or the cooperative banks, they will become very crucial in providing us help to all these IP owners. Because especially for the less empowered groups like craftsmen, farmers, weavers, artisans, etc., they do not have that kind of money that they can generate products, they can make products or copies of products. So that's why they would need that help initially, so that they can start getting some money, so that they can at least enter the market. So that's why we see that from that perspective, it becomes very, very crucial. And the Department of Promotion of Industry and International Trade, that is DPIIT, that has been given the monitoring authority, everything related to the operations and the monitoring will be taken care of this particular ministry. So that's why we see that there are all these things that have been taken as a part of the highlights. Then even there are things related to the generic drugs. What about generic drugs? We'll discuss a little later, so just wait. And then the review. That policy will also be reviewed after every 5 years, and hence it will help in updating it according to the requirements. So for example, let's say today, we know that artificial intelligence has entered the world. So how artificial intelligence and how everything related to artificial intelligence can have an impact on IPRs, on the copyrights, on the patents. So all these things also now have to be updated accordingly. There are so many platforms that would now generate content based on artificial intelligence. Then how do we look at it? How do we solve that problem? So there are all these new aspects that have started to coming in. So that's why every 5 years there will be a review and there will be an update. So that's why the benefits basically are derived from the highlights itself, that the interest of the right owners will be safeguarded better now. Similarly, there has been a reduction in the window for trademark registration that we have seen. That registration of trademark used to take certain years before you could be granted the registered trademark. So now we see that that has been drastically reduced. That window has been drastically reduced. So that also we have seen. Then as I told you that there are multiple direct and indirect tax benefits that will also be there, especially in the innovation, in the tech sector, in the research and development, in all these cases. And then after that, it will also cover the films, music, industrial drawings, etc. All these things which are newer aspects of intellectual property rights, they will also be better covered as compared to what we saw until now. So that also will be a very, very important fact. Then after that, we see that even semiconductors, designs, and geographical indications, trademarks, etc., they also are being covered. So especially semiconductors, given the last decade, we have seen that so much of development has happened in the electronic sector. It also means that it's required that we need to have a regime, a mechanism that can take care of that also. Then also improving the access to healthcare, food security, and environmental protection. And especially the point on environmental protection is something that has become very, very crucial in today's day. Because when we are looking at environmental protection, what we see is that a lot of companies today, they would make something and they would say that it is sustainable, right? These are words that are so often used, whether it is sustainable or they would say that they are eco-friendly. So all these terms are very often used, correct? All these terms are very often used today. Now, many times we don't even know that whether whatever they are claiming is correct or not. We don't know. At our level, it's almost impossible for us to even know whether it was sustainable or not, whether it is eco-friendly or not. The company would say something to make their point. They would say, just for example, let's say a company will come to you and the company will say that, look, we are not giving charger with our mobile phone because we want to become eco-friendly. So that's why no charger. You just buy the mobile phone without any charger. And why? Because we are not giving the charger. That's why we have become eco-friendly. That's why because we are saving some plastic and we are not using that plastic. So the biggest of the companies, two of the biggest companies in the world of mobile phone manufacturing, they are claiming that they have become eco-friendly by not giving the charger with the mobile phone. Now this makes no sense. I mean, frankly, it makes no sense, because until you can say that, look, my mobile phone charges on solar energy, that's why we are not giving the charger. Then I accept. Okay, then I accept that fine, you don't give the charger because your phone works on solar energy. But that's not the case. They have to be charged. Assumption is that if you are buying the 14th or the 15th version of the mobile phone, you already have the 13th and the 12th version, so you should have the charger with you. So why should I give you the charger? You would have the charger with you. But that's not the case always, right? I may be switching from one company to another or one platform to another. In that case, I need that charger. Now I need the charger. I have to buy that charger. What happens next? Let's say I go on Amazon and I place an order of a new charger, and I place it on a prime delivery, on a 1 day delivery. So what then happens is that within 1 day the charger has to be delivered to me. First, the charger will come from its warehouse to the airport. From the airport, it will fly to my city. From there, it goes to the warehouse. From the warehouse, it is finally delivered to me. Look at the carbon footprint of all this function. Instead, if the charger was given to me with the mobile phone, you could have saved all that carbon dioxide. How do you then say that you are sustainable? You cannot. You cannot just claim that, because just thinking that people will not realize, people will not understand that what you're doing is not entirely ethical. It's not entirely correct. You have to lay down all the information in front of the public, that when do you say something is sustainable and eco-friendly and when it is not. And that is something that a lot of companies, and it's not about only these two companies, and it's not that I'm trying to single out these two companies. Right. So what you can do is very simple. That you ask the consumer: does the consumer need the charger or not? If the consumer does not, sell it for a lower price. If the consumer needs it, sell it for a higher price. That's the only thing that they have done. They have basically improved their profit margin by not giving that charger, because they are saving that manufacturing cost with that charger. Otherwise, if they give it, they have to incur that price as well. So that is something that basically they are trying to hide as being eco-friendly. It's not eco-friendly. Sorry. So that's why we see that this is something that happens not only in the electronic sector, but it will also happen everywhere else. For example, let's say in the textile industry also, the biggest of the clothing brands, if you look at, you just go on Google and take it as an exercise. Just go on Google and look for how much fresh water is wasted by the textile industry, and compare it to other industries. You'll be shocked the amount of water that is wasted in the textile industry. Not only that, some of the biggest of the brands, most selling brands in the world, they are also called as fast fashion brands. I don't know whether you've heard the term fast fashion. They're called as fast fashion brands. Why we call them as fast fashion brands is because whatever they make it in a manner they know that they are setting a trend, and their trends are also followed by people across the world. So that's why whatever they do, they don't need to make something that will last for years. They don't need to make clothes that will last for years. They just need to make clothes that will last for a year, maybe 6 months of time. That's it. Because the consumers who are also loyal customers of that company, they are also into buying a lot of clothes or into changing their styles and everything according to the trend. So that's why they don't need to have long-lasting, sustainable clothing. So that's why these are called as fast fashion brands. That their fashion changes fast, their trends change fast. That's why these are fast fashion brands. Now, in all these cases, also a lot of textile is wasted. A lot of wastage is generated. At the same time, a lot of fresh water is also wasted. So that's why we see that this becomes very problematic, because let's say they are not basically making anything for consumers who want to have the same clothes for years. Let's say a consumer like me who will just buy something and keep on using it for as long as I can, until the clothing itself just folds hands in front of me saying that please let me go now. So there are not a lot of these kind of consumers, unfortunately, and that also leads to a lot of these companies also flourishing. So we see that all these things are there, and this is something which is also called as greenwashing. This concept itself is called as greenwashing, where they are trying to show themselves as being environmentally friendly, but in reality they are not. All right. So that's why it is called as greenwashing. So we see that there are all these things. It also makes a conducive environment for investment by attracting both domestic and the foreign investors through a stable IPR framework in the country. So that's why we see that there are all these things related to the basic understanding of how the things work in this particular sector. So That's why it's very crucial to understand the various values and the benefits that we derive from the national IPR policy. Now, overall, when it comes to this policy, one thing also to understand is that this is something that will also have, or it is something that has also posted some challenges for India, because what we have seen, for example, is that a lot of these IPR regimes, a lot of these IPR policies or the parts of the policy is not liked by other countries, by some other, especially by the developed world. They have some reservations against what we have here. So there are three, four important problems that India has been facing and controversies that India has been marred with. So just need to understand these. So first, for example, with regards to something called as compulsory license. First problem with regards to compulsory license. Now, when it comes to this compulsory license, you have to understand that this is something that compulsory license has been one problem. Then one problem has been data exclusivity. Then another problem has been around section 3 of the Indian Patents Act. And fourth problem has been around copyright enforcement. So these are four problems that we have faced. Okay, these are the four problems that around which we have to have our discussion. First is about compulsory license. Now, what is compulsory license? Compulsory license is something that a country can give to a creator or an inventor under emergency conditions. Understand this, that there are conditions that we can say that these are emergency conditions. For example, let's say a condition like, let me just give you an example. Suppose that during COVID-19, the COVID-19 vaccines, for us, they were available, you can say cheaply, for 700 rupees or 300 rupees, and even for free in some of the government hospitals. So 700 is probably the most that we had to pay. Now, let's say what could have alternately happened is that suppose a company that has been the only manufacturer of vaccines, it comes to India and it gets the patent. Right? It gets the patent for its vaccine. After getting this patent, they decide that I am going to sell this vaccine for rupees 1 lakh per dose. So if you need 2 lakhs, if you need 2 doses of this vaccine, you need rupees 2 lakhs. They can do anything that they want. Right? They can do anything that they want because they ultimately they are the owners of this copyright, of this patent, and they have the rights over whatever they want to do. Now, let's say if the vaccine was available for rupees 1 lakh per dose, and that's rupees 2 lakhs for the 2 doses, and rupees 3 lakhs if you are taking that additional booster dose. So then in that case, it would have been a nightmare for us. Right? It would have been a nightmare because then after that, it would not have been possible for everyone. It wouldn't have been possible for everyone to just go and buy that vaccine. Many of us perhaps would have that money that we would have been able to, but many of us wouldn't have been able to. Correct? We wouldn't have been able to. We would have not had any option. Maybe we would have taken some loans or some kind of loans from banks or maybe from somewhere to take that vaccine. So ultimately, it would have been a big economic dent for a lot of people. And this was possible. This could have been done. Now, under this circumstance, if let's say some company had decided to do something like this, this is where the government of India could declare that, look, this is an emergency condition, and because it's an emergency condition, we are allowed to give out compulsory license. And then government of India would give compulsory license to an Indian company. Suppose that there is one Indian company who has been given the compulsory license. Now, this company will be given all the information about the vaccine, because for any kind of patent, what we discussed is that you need a complete public disclosure, right? You need a complete public disclosure, meaning that you have to give each and every information about this patent to the government. Government needs to know about each and every minutest of the details. So that's why the entire procedure, all the ingredients, and each and everything is known to the government, and government simply takes this information and gives to an Indian company and ask that Indian company to make the vaccine as cheap as possible, because nobody is going to take any benefit out of it, any profit out of it. That company is not going to, or is not allowed to get a lot of benefit or profits out of it. And government would pay some amount of money to the original company, saying that, okay, fine, we are giving compulsory license to other companies, so you take this money. So ultimately, that company would have lost a lot of money because of that. So that's why the companies, before entering this market, they will also know that this is going to happen. So let's not keep the charge or the price of this vaccine very high. Now, this is something where we see that a lot of controversy also has been created in India around the same uh, uh, compulsory license, because we have seen that there have been concerns regarding something called as a generic drug. The problems largely that have happened in India, they are around generic drugs. So generic drugs basically are the drugs or the medicines which haven't been produced or manufactured by the patent holder company, but some other company, which probably has been given the compulsory license. And it happens a lot in India. India has become a hub of generic drugs, where a lot of generic drugs are being produced and being sold in India. And because of that, we see that generic drugs is where we often see that generic drugs is often where we see that a lot of companies have a lot of reservation against India, saying that India simply would create a generic drug out of whatever we come up with, and that's why we would lose a lot of money, because generic drugs often will have a much cheaper price as compared to the patent holder company's price. So that is where we see that all the controversies have been, that India has become a hub of generic drugs, and this is something that is not liked by many of the Western companies based out of US and the Europe. But compulsory license is something that is allowed. It's not that only government of India has this rule. It's an internationally allowed rule under the TRIPS agreement, so of the WTO. So that's why it is allowed, and every country has the right to exercise these compulsory licenses wherever they need. Now, what happens is that this also brings down the cost. It really brings down the cost of the medicines, etc. We have seen this with AIDS. In the case of the AIDS medicine that does not really cure AIDS, but it can at least help people live longer with AIDS. So now what we saw with this kind of a medicine for the first time, and this also all the controversy was around India only, because what happened is that AIDS, the understanding of AIDS developed very late, because we did not understand how AIDS functions and how exactly this virus transmits. The understanding, by the time the world had an understanding, already the number of cases of AIDS were more than lakhs in numbers. So, and there is no cure, there is no medicine. So it became a very big challenge. Now here there was one US-based company that had a medicine. This medicine they were selling at $8,000. $8,000 was the cost. So just calculate in today's terms, in rupee terms. So $8,000 was the cost. Now, with this $8,000, you would be able to at least live with AIDS, live longer with AIDS, but you would have to spend $8,000 per annum. That's not possible for everyone. We are talking about somewhere around 6.5 lakh rupees in today's value. That's so much of money. If you have every year, then only you'll be able to survive with AIDS, otherwise not. The problem with AIDS also was that the countries that were suffering from AIDS, these were largely the poorer countries, and that to the poorer section in those countries were the ones which had the highest numbers of AIDS cases. So that's why it was impossible for them to even think of having those $8,000 to at least survive with AIDS. They could not. Now, in this particular scenario, an Indian company, Cipla, comes forward, goes to the government. It was the Atal Bihari Vajpayee government at that point of time, and Dr. Yusuf Hamid, who was the head of Cipla back then, he came forward. He said to the government that, look, if you allow us to manufacture this, will bring down the cost to $2 a day. This was per annum. This was $8,000 per annum. They said that we'll bring it down to $2 a day, and if you allow us to mass produce it, we will bring it down to $1 a day, meaning just almost $350, $360 per annum. So from $8,000, they would bring down the cost to just $350. That is the claim that Cipla had. Now what happened is that the government of India allowed. The government of India said that fine, you start. Now this was a big controversy because this company obviously did not like it. That they were the only ones who knew how to produce this medicine, and nobody else knew. And they had the big market in the entire world. And now there is India, which has allowed a normal company like Cipla to start manufacturing this medicine. It created a lot of controversy. This company did not like it. Many times what we have also seen is that all the pharmaceutical companies, they start working like a cartel, and this is what happened here as well. They started working like a cartel, and they all started putting cumulative pressure on India to stop Cipla from manufacturing these medicines. So much so, just imagine, this is where we are talking about saving lives, because what India did was that India mass manufactured it, not only used in India, also supplied it to other South Asian countries, Pakistan, Bangladesh, Sri Lanka, etc. Also supplied it to African countries as well. So India supplied it to everyone. India supplied it to everyone for free. It was just given for free, without any cost, without any charge. And then there is this opposition which is coming from these companies saying that, why are you trying to save lives? Basically, this is what they meant. Not only these companies. At that point of time, George W. Bush, the president of the US, even he started putting pressure on India, saying that we will start putting economic sanctions on India if India does not stop. This is the scenario. On one hand, we are taking all the losses, we are just distributing it for free. On the other hand, there are all these developed countries with all the resources, all the money, and opposing India from doing that, putting pressure on India to not try and save lives everywhere else. Thankfully, what happened at that point of time is that India got a support from a lot of other countries, a lot of different nations, and also from a lot of, you can say, NGOs, etc. as well. There were a lot of protests that started happening against the US, not only against these companies, but even against the US, and in US as well. Not only in India and elsewhere in the world, but even in the US, there were a lot of protests. So in all these cases, what we see is that it really helped in getting India to start mass manufacturing it. And there are case studies that have been published on it, that how India averted a pandemic. This was a case study of how India averted a pandemic. So such a scenario is where we see that if let's say we had budged to this pressure, if we had succumbed to this pressure, we would never have been able to do something like this. So that is why this became a very, very important case study regarding this. Then there is something called as data exclusivity. So in terms of data exclusivity, what we have seen is that many of the multinational companies, again in the pharmaceutical sector and also in the agrochemical sector, they have been saying that in India, their data is not safe. That even if their IPRs are safe, their data is not safe. And many times these data, the research data, the background data, etc., they are very easily available in India, and that's why other companies are able to replicate these products even without having the IPRs. So that's why Indian laws do not protect against unfair commercial use of test data or other data submitted to the government. So this is what has been alleged by many of the bigger MNCs and pharmaceutical companies. So that's why they want that India should also have a data exclusivity law and try to protect all these things. Then one more problem has been the enforcement of the Copyright Act. That the Copyright Act enforcement is not that strong in India. We see that very easily. For example, especially if you are in Delhi or around, you would see that very easily the photocopies of books are sold or pirated copies of the books are sold. And not only in Delhi, other parts of the country as well. You'll find that very easily all these are being sold in the country. So that's why we see that this also has been a problem. That if we can see, obviously the enforcement agencies can also see it, and that's why in all these cases, this is something that becomes a challenge for everywhere, and especially for the companies that are owning it, for the authors who are owning it, for the publications who are owning it. For them, it's a big issue. So that also needs to be taken care of very well. So there are all these problems, and then lastly, there is the problem of the Section 3 of Indian Patents Act. Now, in Section 3 basically is about providing an exclusion. Alright, it is basically about what can't be patented in India. So what can't be patented in India, these are the things that are covered under Section 3. So many of the Western countries, they are saying that India should not even have this Section 3 because this Section 3 stops many of the companies from functioning well in India or doing a good business in India. Now, this is a basic premise of philosophical difference that India has with the West, or even countries like India and China or Eastern countries in general. You see, they are different from the Western countries in the IPR laws, because here we see that a lot of exclusion has been provided so that we can serve the people of the country first, and then you can say the profits or the benefits for the companies. So, for example, anything that is natural cannot be patented. Anything that is natural, for example, you cannot simply patent a plant. In the US, let's say you discovered a plant, you have gone on for hiking and you just found a new plant which has a medicinal property. You can simply go and get it patented. In India, you can't. Anything that is natural, a seed variety, a plant variety, cannot be patented in India. So that's why these companies lose a lot, because in US, in Europe, they can very easily they could have gotten it patented. In India, they cannot get it patented. So that becomes a challenge for them. So that's why we see that these kind of exclusions are there. Then also we see that there is an exclusion against patent evergreening. That unless there is a significant change from the original product, you cannot get it patented again. So evergreening also in India is very, very difficult. So that's why we see that there are all these exclusions that are there in the Indian Patents Act, and that is also something that is not liked by the Western companies and the countries, because they feel that it makes it very difficult for them to do commerce in India. But thankfully, this also helps in a lot of ways. Then the last topic for the day, the last topic is traditional knowledge digital library. Now, this traditional knowledge digital library is a digital library, or you can say an online library of all the traditional knowledge of the country. One of the biggest challenges that we saw, what we also discussed, was that a lot of our traditional knowledge was just being patented elsewhere in the world, right? So now this is where we felt the need that there must be a mechanism that can help us against this wrongful patenting that is happening elsewhere in the world. And a lot of this traditional knowledge, one of the challenges that we have with the traditional knowledge is that a lot of traditional knowledge is available in some language or the other. Correct? There are so many languages in India and there are so many dialects in India that from one region to another, it completely varies. You just go 100 kilometers from one place to another, the language would change. So that's why a lot of this is in the local language. Maybe some in Sanskrit, some in Tamil, some maybe in Kannada, some maybe in Odia, some maybe in Punjabi, some in Hindi. So there are so many languages that we have, and all these will be in various different languages. So now what was decided? That all these things that we have as a part of traditional knowledge in various different languages, they should all be translated into 5 international languages. 5 international languages, and this was a decision taken by the CSIR and the Department of Ayush, now that has become Ministry of Ayush. So they collaborated together and they made this digital library where all this traditional knowledge will be available online. And they will be translated into 5 international languages: English, French, Spanish, German, and Japanese, and it will be publicly available. It will be publicly available so that nobody can simply come and get it patented. Because if they get it patented, India will fight it and India will not let it get patented. So that is why we see that this kind of a database of all the traditional knowledge of the country was made. And today we see that there are more than 2 lakh papers that have been basically made in just the medicinal properties and everything that we have found in the traditional knowledge of India. So that's why it provides a kind of a defensive mechanism to the rich traditional knowledge of the country. So that's why in all these cases we see that it becomes a very, very important fact about saving our protecting our traditional knowledge. So this is about this chapter, and this is it for the segment of science and technology. Now, tomorrow, as I told you, that there will be a doubts section. If you have anything that you want to ask, please send it with this subject, doubts underscore science and technology, so that we would know, and the team will send me all the questions also, so that I also will be able to address all your questions in advance. So in all these cases, we can actually take your questions in a much better manner. So any question if you have with regards to whatever we have discussed, please let me know, and then we shall end the discussion for today. Leaderboard, okay. Leaderboard for the day. This is the this is the leaderboard today. Tomorrow only doubt loss or something will be covered. Only a discussion on 2023 prelims question paper I'll do. Otherwise, it will be more about your doubts. New law have loosened some of these patent rules. Are we going to study it? There are some technicalities there, and depends on the movement that happens over the next few months that we'll have to see it. What happened to CIPLA? Nothing happened to CIPLA. CIPLA still exists and is doing well. Yeah. So this is the leaderboard for today. Cambly is one app for English practice. Okay. So anyone who wanted to know, the name of the app is Cambly. If you don't have any doubts, is it compulsory to attend tomorrow's class? It depends on you. There will be, there can be new things that will come up in the discussion, so it might help you. Otherwise, it's your decision. Where to send? I've just written it on the board, on the screen itself. You can send it to IS Live. You can send it to islive@byju's.com. And further from here, if you have any doubts that you want to ask me, you can always write to me at rashesh.kumar@byju's.com. There are some emails that are pending for me to see. I have not been able to, but I'll do that over the next few days. So if you already have sent me any email, I'll also answer them over the next few days. Bitcoins are created in specific quantities. How won't regulate mining exhaust Bitcoin reserves? See, when it comes to any new transaction that is happening, the mining will keep on happening. So it's not always about creating new. It's about the you can say the recycling of all these quantities also that keep on happening at the same time. But just when it comes to the Bitcoins, these are being, the mining is happening, the creation is happening for every new transaction, and these new transactions are creating this. And because this is a digital currency, it's not that it is adding to the physical form. Do you know why Batman doesn't cover the area around the mouth? Not a question for this session. Last year, government imposed 30% tax on profits generated from crypto trading. How will government get to know whether amount is generated from trading or any illegal activity? Because when you are trading in your own money. So for example, let's say you bought 1 Bitcoin. So to buy that Bitcoin, you have spent 20 lakh rupees. So it's not that you are spending that Bitcoin. You are spending your money here in trading. All right. So that's why in trading, because you are spending on your own money, the tax is being levied on the benefits that you have from this money. What is the solving complex mathematical problems in blockchain technology? My imagination is typical mathematical equations. Is it like that? No, it is not that. Basically, see, complex mathematical problem is not really the complexity in the mathematics, but rather it is the complexity in the computation. Basically, it is what I'll tell you. The addresses that we discussed, the addresses are not simple ABC addresses. The addresses can be 56 character encrypted addresses. So now you have to decrypt those, find those 56 characters, and that is what you have to solve for, and that can take time and effort. The books issue and issue you have written about, we are trying to solve that issue as quickly as possible. We are in contact with everyone that as soon as possible we'll do that. Bitcoins were manufactured in limited quantities, so in future if all the Bitcoins are exhausted, how will the reward mechanism work? So basically, see, the reward mechanism can work as long as you are doing any kind of work with regards to or any kind of transaction, any kind of new transaction that you're doing. If it is recycling, then new mining cannot happen. Right, so let's end the class today here. We'll again come back tomorrow, same time, 6 a.m., mainly for your doubts plus 2023 prelims discussion. This is what we are going to do in tomorrow's class. Thank you very much.